Okay. Save a DM on Reddit. Ah. Okay, so yeah, the last time we did math, we looked at this limit involving a square root minus x. We found it should be 9/2, but I was having a hard time trying to like help someone out actually getting to that answer in text. Because you can do it a few different ways, and I don't know if this person's supposed to do it a specific way. Yeah, it was. Factorio used to be like I used to only play Factorio and Daisy on stream. But my Factorio run kind of felt like it came to an end. So I started doing Satisfactory instead, and then I got bored of Satisfactory too. So I plan to get back into Factorio though. Right. This is to explain in a text post, but if you're with me up until the let's go from there. An x out of the numerator and an x out of each part of the square root. Actually, no, factor. Just start with the square root part, because that's going to be the weird part. Another math tutor you work with both sectors. Are you excited about some new content that's supposed to release this year? Yeah, I'm super hyped for it. It's going to be in August. And I've been wanting to start up a new Factorio playthrough sooner than that, but I also kind of just want to wait for it to come out. Yeah, they're doing a whole DLC that's going to basically be an entire new Factorio on top of the existing one. Hey, Bladwy, thank you. Okay. And then let's bring the x squared outside. Now bring the x squared outside the square root. Too many enters. Yeah, so I'm probably going to Factorio on stream at some point over the next few months. I don't know if I'm going to have the patience to hold out for the DLC coming out or not, though. Top and bottom. Prefer to have LaTeX? Yeah. I was trying to avoid doing this exact explanation when I wrote this post for that exact reason. I don't know if what I'm doing right here is going to even make sense to the person, but I don't know about another way to communicate it. And they're asking about this exact thing, so like, what the hell else do I even do here? I guess I could like post an image, but that's kind of a pain. Now take the limit as x goes to infinity. I was avoiding that part because it's a little hard to explain in a text post, but zero, zero, 0, 9 over square root 1 plus 1 equals 9 over 2. It is, yeah. I mean, I guess it doesn't really affect me much aside. Well, I guess it does affect me because the stream is going to slow down. So sick of tutoring intro stats. Oh, man. That's fair. All right, so like, because I think you mentioned that you manage a tutoring center, Fenbucks. So like, what do you all do over summer? I assume there's still like some business to be had, but it's not nearly as busy. There's at least two other ways that evaluating a limit like this gets taught, but the explanation above is a pretty safe one, accepted in most classes. Like, it's this part that kind of makes me nervous about showing a specific way of doing this limit, because if they have a strict teacher, they may not be supposed to do it this way, but this is all pretty, like, valid math, at least. Reduce our hours with them, say close on Fridays, but we're still open, just way less busy. Oh, okay. Yeah, this will be my second summer doing a math stream. And last summer, I went kind of crazy with how slow it went, so I just kind of stopped doing math streams for a good bit there. I think that this summer will be a bit easier with me actually being interested in studying things again, so I'm probably not going to completely like nuke my schedule for a few months like I did the last time. But I don't know. I'm gonna have to see like how it actually goes, because my favorite thing is actually like helping people out. So when that isn't, or when that doesn't happen, then it's like, I don't know. Your college mainly only offers online math classes in the summer. Oh, that makes sense, I guess. But yeah, it does suck for the tutoring part of it, for like a physical tutoring center. Are they asking to prove the formula for the summation of the geometric series? Yeah, I don't know if I heard that exact term. Like, what else would I call it, though? I guess just calling it the sum, I guess, or the infinite sum. Make sure no one has beat me to it. About the formula for the infinite sum of a geometric series. S equals A over 1 minus R. The parentheses are confusing. Let me just do a comma. An infinite sum, as opposed to a partial sum. The term convergence value refers to the idea of taking the limit as the number of terms goes to infinity. The sum of the series converges to a particular value. Sum of a geometric series to a particular value when absolute value of R is less than, strictly less than 1? Yeah, because if it was equal to 1, I don't think you're decreasing, right? Convergence of a geometric series. So the homework was pretty cool. I never saw it until you started streaming it. Yeah, I have my gripes about like there's some practical issues that come along with like trying to get questions off the internet like this. Like I'll spend a lot of time on my answer, then I'll realize someone else just like posted a one sentence answer that kind of covers it. But it's like a neat resource that's out there. I didn't even know about it until I looked into something to fill the time for the stream, because I think my ideal math stream is just having questions, a constant stream of questions from chat, and being able to actually have that interaction. But you know, you don't just build an audience overnight, so I need something to do it in the meantime. So I started looking around just on Reddit for like homework help things. Hey, Phobos, how's it going? Okay, I hope I'm not overloading with math terms, but I think I've explained what their question is. Or I think this is a sufficient answer. Let's sit down for algebra studies. Oh, nice. Yeah, I was able to work a little bit on your stream yesterday, but I keep like either being in bed asleep during your morning streams, or I'm like busy during your evening streams. But I do want to catch more of them. When are you studying differential geometry? Probably no time soon. I haven't studied it before. Okay, Gamma Raybur's got this one. These shapes are different. Where's my PhD? The Leibniz rule. Leibniz? I don't know. Just kind of curious what this says. If you're taking the derivative in terms of x, I just haven't seen this before, so I'm kind of curious like what's actually saying here. If you take the derivative in terms of x of an integral function with the integral in terms of y, you can bring that derivative in as a partial. I mean, if they're both linear operators, I guess you're allowed to do that. I don't know though. I feel like I don't exactly know what I'm talking about when I say the term linear operator though, so maybe I shouldn't say it, but. Oh my god, this is is this another version of Feynman integration? I'm still looking at part C there. Okay, anyway. It already has a response, so I'm not gonna add my own, but I run back to the 100 red and blue marbles. Oh, I don't know the question was. That sounds super weird though, that there be a relationship there. Oh, Gamma Ray Burst again. Oh my gosh, got an essay here. Uncle Laner got it. Oh, a tree diagram for stats. This makes me nervous, but let's see. There's no response. Half as the probability for statistics and calculus? What? Oh, okay. I thought this was like calculus-based stats for a second, but no, it just this is like it has the word calculus in it though, but I believe that helps. Okay, so I just has the answer like drawn out for us here. What's the actual? Why do you write half as the probability for stats and calculus? Where is the half? Oh, right. I think it's those two halves there. Stats class has 14 females and 12 males. Calculus class has 6 females and 16 males. If one of the class lists is chosen at random and a student is chosen at random, find the probability of selecting a male, a female. The stats class, if the choice is of... What is the phrasing on that? Okay, given that we chose a female, what was the probability that female came from the stats class? Well, this part isn't even relevant with the person's actual question. How would I do that, though? I feel like that's something that I should know how to do. So given we chose a female, means... Do you do... Daisy rule? Okay, that's probably it. Yeah, you're right. I always forget about Bayes. So we want the probability of choosing stats given we chose a female. So we do the probability of choosing a female given stats, which is 14 out of 52. Wait. Wait, now I'm confused by this tree diagram. Why is this in the middle here? And why does female not have an E in either one down there? Well, I guess the second E. I mean, I guess I could just look at this part and not question it too much, but I'm confused why these two are different. One is P of F given S, the other one is P of S intersect F. It's multiplied by a half. I mean, that's just showing the step. I don't know. But anyway, 14 out of 26 times probability. What was A and what was B? Oh, it does say independent probabilities there. When Bayes' theorem is useful, when they're not. I imagine they don't need to be independent for this. Hey, SPQ. I mean, I think well, I mean, for the sake of the formula, though, you consider P of A and P of B independently? They're not saying in general that A and B have to be independent. I don't know. Okay, wait, so we said A is a probability of choosing stats. So we do 14 out of 26 times a half over probability of choosing a female, in which case we have to total all the students, right? Yeah, it might just be a poor phrasing thing there. So probability of a female in general, 14 plus 12, 26. Actually, I mean, they give it to us here. So we do 26 plus 22 for the total students is 48. 20 over 48. How does that reduce? I should be putting this into Wolfram Alpha because I forgot what I said at first now. 14 over 26 times 1/2 divided by, we said 20 over 48. 42, that seems reasonable, sure. 65% chance. I mean, that seems pretty reasonable. You have more than twice, I guess, the proportions. I mean, 6 females versus 14. I expect to be like more, like, I expect stats to be the majority of the probability, I guess. So that wasn't even their question. I was kind of doing this so I could remember how to do stats. Their question was really, why is P of S 1/2 and P of C 1/2? And that's just because of the setup of the question. Let's make sure no one else beat me to it. They get 1/2 for P. I just realized, why is P lowercase? Who makes probability lowercase p? I'm going to capitalize it. Thunder, thank you. And since we're not told otherwise, probability. So 1/2 and 1/2. Okay. If P is lowercase, you're weird. The negative binomial distribution, is that the one where it's like the probability of your first success on X trial? Oh, never mind. The geometric series is what I was thinking of. The negative binomial is the rth number of success on the nth trial. Number binomial of fixed trials, negative binomial of fixed successes. Oh, you're finding the number of trials, really? I bet you I can remember how to apply it if you have a question about it. Or are you asking like more conceptually? Number of trials is not fixed. It says the number of trials needed to make R successes. Oh my god, there's so many ads on this page. I want to see an example of a problem that this is solving. Okay, good. 15 people must be asked before you can find 5 people. Okay, yeah. That's what I was imagining. Say, okay, if you have x is proportional to negative binomial 3, 0.2, x is less than 4, you don't get how it works. Okay, so this is gonna be like cumulative negative binomial if x is less than 4, right? So, it's been a minute since I've done this problem, so I'm gonna have to like remember it, but 3, 0.2, so, oh wait, so 3 successes, 0.2 probability, and we want the number of trials to be less than 4. Okay. You can convert the negative binomial into normal binomial. Yes, that's because like even though I have it right here, like this is basically the binomial distribution. We're just plugging in slightly different numbers. Why would x be allowed to be 0 though? How would you ever get a success in 0 trials? You need at least more trials than successes. Zero fails before R successes. Since negative binomial answers the question, how many trials do you need for fixed S successes? Oh, I get it. The formula kind of compensates for that. You always start it from 0. Or x always starts from 0, but it's not actually 0 trials. That's kind of confusing though, I guess. Like they literally say x is the number of trials, and then they say down there x starts from 0. but the formula kind of takes care of it for you. Okay, so you DM'd me the actual question, Thunder. Let's take a look-see. Question 9 and 10. Let me switch up the music. Okay. So question 9. The random variable x has a negative binomial distribution. 5 successes, 0.7 probability of success. And for part A, we need x equals 10. Right. You Perpies were brain no good. Yeah, because I don't think calculators, like, do they do the negative binomial distribution for you, or do you have to convert it? Like, you have to compensate for the numbers yourself? Because the formula is basically the same, but you got to convert. Okay. It's similar. I don't want to tell you the. Ugh. Yeah, I don't know exactly how. You need to enter it into a calculator. Oh, they do a program. That's cheating. What is this? Oh, that's another program. Yeah, I. Why are there like no resources on this? Because like that's something you definitely want to use a CDF for, or like everything from like B, C, and D. Like those would be a pain to calculate by hand. It's been so long since I've actually had to work in a calculator that I don't remember how you actually do this. I'm sure I've done it before. I feel like this would be something that Dan would know. Like maybe like try DMing him. Probability to get 5 successes in 6 or fewer trials when each success is probability 0.7. Thank you, Bob. Yeah. Since NB 5.7, x less than equal to 6. 5 successes and 6 or fewer trials when each... Well, it's not just 5 successes and 6 or fewer trials, it's... the 5th success on the 6th trial. Or less, I guess. You know what? I guess you're right. Does this just convert back into like a normal binomial? Part B is asking to find the probability that the 5th success occurs either on the 5th trial or the 6th trial. Okay, underscore. That's probably it. Actually, to ingest the normal binomial with x equals 6, does that get us the exact probability that we want, though? I want to look at the formula with the choose again, like... That's not the exact thing that I want. Nah. Is it this side that I was looking at? Okay. I mean, I guess we could verify it. Okay, let me just... Negative binomial distribution. Calculator. Just see what the site tells us the answer should be, and then see if we can reverse engineer it from an actual binomial distribution. Probability of success on a trial. We said it was 0.7. Number of trials. 6. Number of successes. Wait. Oh yeah, 5. Well, that's x equals 6. Ugh. Hey, Eldritch. Can they watch stream soon now in Witcher 3? Oh, okay. We'll see you then, Bob. Hmm. Is the times 5 basically the result of that choose? Like, I'm trying to think about like generally, like the general advice we can give to Thunder when they see other types of questions. I'm gonna send a message to Dan and see if this is something he happens to remember. Oh yeah, Thunder, if you could. Actually, okay, yes. In that case, I won't message Dan quite yet. So we might be able to just figure it out here if we can figure out what the pattern is from the answer. Okay. So for part B, it is p of x equals 5 plus p of x equals 6, but this is like negative binomial, this. 0.7, 5 choose 4, which that is 5. Really, so did you just manually calculate it here? I kind of hate it. It's like, okay, the thing I'm trying to answer in my head is that, is this just a binomial, like a binomial distribution with, binomial distribution? Yeah, I saw that part C is a bit more like complicated, but like, I feel like I don't even understand part B yet. Sum of trials 0.7, number of trials, let's call it 6, number of successes 5. 0.252, we don't have that anywhere here. Hey, Ipsum. Because yeah, we do have the constraint that it's this is any 5. Actually, it doesn't match the final answer though. 4202. Ooh. What? Why would that one match? X greater than or equal to 5? Because we only have 6 trials. Ooh. Okay, that man, I'm really rusty on these. I guess let's look at part C though. Describes calculating probably the 5th success occurs on or before the 15th trial, but why be the number of successes in 15 attempts? The number of successes in 15 attempts. So I have a silly question. I just can't get why calculating an area behind a curve can be that hard. Like integration? Like, do you mean actually finding the antiderivative? Well, okay, I would say if you're willing to do a numerical method, integration is super easy. And by numerical method, I mean like getting estimates. The actual idea of it is really simple. The hard part comes in finding the antiderivative with which you need to have the exact value of the integral. And my explanation for why it's so hard to find the antiderivative of a function is that derivatives are defined like in a really clean way where everything you would normally encounter has a really, it might be a mess of algebra, but has a very like step-by-step procedure. Like there's nothing that doesn't have a derivative as long as it's continuous and indifferentiable, which I know continuity is part of being differentiable, but and then integration is just the reverse of that very clean process. And it turns out that reversing that process that is normally very clean is not at all clean. That's kind of like the brief explanation that I can give, but like they defined it very well in one direction and then just let the other direction kind of work out however it's going to work out. Let's go back to reading third part C, though. Requires calculating the probability that the fifth success occurs on or before the 15th trial. Is that supposed to be y minus b, or is that some weird equal sign with a typo? I think it's supposed to be an equals. Or like the tilde. Okay, yeah. That makes sense then. So the fifth success occurs on or before the 15th trial. If y is the number of successes in 15 attempts, then y is the binomial distribution for 15 trials with a 0.7 probability. So x, the negative binomial probability, being less than or equal to 15, is equal to the number of successes being greater than or equal to 5. I guess that makes me uncomfortable, though, because that includes 6 successes, 7 successes, like... Okay. But maybe it doesn't matter with the way that this is built. If you have less than 15 trials, then why is that 15 trials are fixed? Okay, it sounds like underscore is giving the more like pure math type of the answer. Yeah, I mean, I just think it's like a one-way door, I guess. It's very easy to go through the door one way, but it's not easy to go back the other way. Like a trapdoor function in the computer science world. Like hashes and all that, but that's probably not the best metaphor if you don't know that. If you have less than 15 trials, why is it that 15 trials are fixed? Yeah, it's like the way that the negative binomial setup is the number of trials are fixed, but when you have x is less than or equal to 6, you consider a fixed number of trials 6 and then 5, and then you don't go less than 5 because we're only asking about 5 successes. Stone pressure plate. Like in Minecraft, I'm trying to remember, like, because those ones don't get activated by items, right? But it's still easy to step on it. I don't know. This feels all wrong to me. I'm gonna be honest. 9993. It does match with the answer. Okay, so Thunder, I think what they're saying is that okay, so I guess first for part C, we interpret this problem as saying your fifth success Oh yeah, I saw SPQ, but I didn't even like read it that closely. It's so bad the teacher who got a degree in stats in your school can barely explain it. Yeah, I mean, this is kind of a really weird thing to explain. And critical, yeah, sure. Uh, if they're asking about getting, if it, this is so weird. So when you have a less than or equal to for what they're asking about, I guess it's equivalent to asking getting 5 or more successes in 15 trials. The part that makes me uncomfortable there is how do you know that the last success happens on that last trial? But I guess we just trust that it does. Yeah, you can put it on the Discord, critical. No, this is probability that we're looking at right now. Okay, if we just blindly trust it, I think the rule is. Oh, wait, let me see what we're typing. Why is that 5 or more successes in a fixed 15 trials the same as 5 successes in 15 or less trials? That's kind of my exact question. I was about to say basically that as the general rule that we could follow blindly. I don't understand exactly why. But apparently it just works like an Apple product. Five or you should look at the greater than version. Yeah. It's way more BS. Let's see. This requires calculating the probability that the fifth success occurs after the 12th trial. Let's z the number of successes in 12 attempts. The fifth success occurs after the 12th trial. See, this one actually feels a little bit cleaner to me. Because if the fifth success occurs after the 12th trial, all you have to be concerned about is having exactly 4 or less successes by the 12th trial. Like, to me, the connection here is much more direct, where because they're saying this is the strict inequality. It's basically your fifth success is on your 13th or later trial. So it means that you can have at most 4 successes on your 12th trial. So this translation actually, to me, makes much more sense than the translation in part C. You can't have less than 4. So you can see here, like they did z is less than or equal to 4. So you'd want to do binom CDF. So you, but between like 0 and 4, basically. You can have less than 4 within 12, yes. Because as long as you guarantee that you don't have your 5th success by your 12th trial, you can have them anytime later. Yeah. Because you know that, if you let a number of trials go to infinity, you're going to eventually have, infinitely many successes just with the way that probability works. So all you care about is those first 12 and make sure you only hit 4 at most. So maybe now that it feels like we're both on the same page with part D, so maybe this will help us understand part C again. The 5th success on or before the 15th trial. I feel like I don't even understand the binomial distribution anymore. I feel that. Sounds good, critical. I'll take a look at it after this. I said at your first one. P of x less than or equal to 15 is equal to P of y greater than 5. If our 5th success occurs on or before the 15th trial. I have a theory in my head. I have a very hard time explaining why it works here. Hmm. Thanks for the Prime Thunder. I'm trying to think about how I'm gonna phrase this though. Okay, I guess let's go to the whiteboard. This is not going to be a good explanation. Last time was the Poisson test. Oh, okay. I remember that Poisson question. It took a similar amount of thought. So I want to look at the actual terms of the binomial distribution. Let me look up the formula again. Okay, n choose x, p to the x. So we're saying from x equals 5 up to, we had 15 short trials for part C. Up to 15. Okay. Hey, Skirtle. Do squared. Hell yeah. And choose. Oh, sorry. 15. Choose X. P is 0.7 to the X times 0.3 to the 15 minus X. I think is how we do this, binomial. So all I'm trying to do with this first part is set up what the answer was, or like, hope your Hades was good, Skirtle. All I'm trying to do is set up this binomial distribution for the y and look at each term. So I think I wrote the formula, and I want to see if we can kind of break the terms apart into their pieces and rearrange them so it matches something more like a binomial, or a negative binomial. Oh, hey, tired student. Monday's your final exam, then you're done? Awesome. That's hype. I'm trying to explain the negative binomial distribution. I'm kind of struggling with it, but I think I'm about to hopefully make some progress. You know, the negative binomial seems so useful in real life, but it makes no sense. Yeah. I mean, in real life, you just use a calculator like this one. Trying to do this weird setup thing it's definitely confusing. Okay, so I think I set up the formula right for our y. I can actually... Did I got the order wrong, didn't I? Yeah, 12, 0.7. Or 15, 0.7. Okay. Tired student, the probability of hitting a bullseye is 0 for me. Easy math, nice. So we have 15, choose 5. 0.7 to the X. Oops. .3 to the 10. So this is the first term. If we get exactly 5 successes and 15 trials, what I want to say is that inside of this term, there's only one case. So this is exactly 5 successes out of 15 trials. That 5th success could have occurred on any one of those 15 trials. Yeah, how the hell? This makes no sense now that I actually think about it. 5 successes out of 15 trials. So what I was thinking is that if I like skip to the very last term, something there'd be some kind of more clear meaning with because like if you get 15 out of 15 successes, that's basically going to be like 5 successes and 5 trials, because you would cut off the experiment after the first 5 successes. And I was hoping we could do some kind of similar breaking out of like how each of these terms correlates with that number of success occurring on that trial, but it's really not that clean now that I actually try and show it on the board. This is current any 50 trials makes sense because you have less than 15 trials. Yeah, so I was gonna try to make some point about how like because I guess like the first term that I wrote would be the case. I don't know. This is so weird. I don't know how I think I'm just wrong. Whatever I was thinking. What microphone do you use? I use the Rode Wireless. Me? Not you, but me. Just dropped it. It's a little lav mic, and that's the box that I keep in my pocket. And the actual like mic is right here. Actually, it's kind of hard to show, isn't it? I also have a AT2020 that I use when I game, but I don't use that when I do math. Well, yeah, Bob, we know that we can do that. I'm trying to figure out why we can do that. Like the question is like, why does this whole conversion to regular binomial work? Because it makes no like theoretical sense to me what's actually happening. I guess so. I think I will DM Dan and just see if something he happens to remember that he can maybe explain when he streams next, and I can send you the VOD or something. 9. We're talking about B, C, and D. We understand D, I guess. But basically, Hunter's supposed to convert these negative binomial distributions into a regular binomial distribution and do that without gaming. Oh, yeah. Yeah, I got this like lav mic so I can like go up and go to the whiteboard without like sounding any different, but having like a stationary mic is a bit more convenient if I don't have to leave the desk. Hey Mish, you got math exams tomorrow. Pray for me. I will. Good luck. I don't actually know why they call it negative. So we're looking at the actual answer for B and C. I think B is just like a simplified, like B is really what C is saying. So like C is the more important one. B, they just kind of take a shortcut, I think. Let me just try one last-ditch Google attempt. part C. Like it's basically we're stuck on this step with why is this equality true? We know how to get binomial probabilities, but why is this negative binomial with x equal to that regular binomial with y? Like that's what I can't explain. We're worried about the actual concept, not the calculation. Or how can we apply this to problems in general? And okay, this person's just saying n trials led to r success or more is the same as r success happened at nth trial over 4. If you fail less than 15 times... Oh, okay. Hey, Bluebird. X less than or equal to 15, the fifth success happens in the first 15 trials. Oh. The fifth success happens in the first 15 trials. There are at least 5 successes in the first 15 trials. Huh. Why is greater than equal to 5? There are at least 5 successes in the first 15 trials. Okay, that's kind of a nice way of explaining it, Lubert. I had to read that a few times, and I still have to read it a few more times, I think, but... It still feels a little weird to me that the probability calculations come out the exact same, since I feel like Binomial just captures so many more scenarios. I guess because like the negative binomial kind of like cuts off after the certain number of successes, but when we're talking about doing a cumulative binomial, like in this question, we don't have to be as concerned about it because we're capturing many different successes anyway. If you had 5 successes in 10 trials. I think what do I think? What if you had 5 successes in 10 trials? Is that counted in this probability? Right. Because the binomial has, you know, many different scenarios with 10 trials and 5 successes. But negative binomial was only concerned with the 5th success on the 10th trial. I don't know, there's like a weird thing in there. I might just move on for now. In a minute, if we can't find something, because it might have to do a specific example. Takes a big run of 15 trials. Find what x and y are. Like do an actual simulation. Let's see if there's something that can easily do that. Oh, never mind. That's like doing 1,000 trials. Never mind. Okay, so yeah, you're just using like a string of like ones and zeros. If it's one is success, zero is a failure, then that's a run of 15 trials. Sure. How does that help us, I guess? Is y greater than or equal to 5 and x less than or equal to 15? We do have more than 5 successes. And we did do... I mean, you said 15 trials, so I'm just going to trust you without actually counting the ones zeros, but... I guess they're both true, yeah. Was both be true or both be false together? The events are the same. Hmm. That's it's helping, but it hasn't like completely sunk in yet, for me at least. I'm wondering about like I'm taking the thing that you wrote and like chopping off, like like that last one or something, but that would break what we said about the binomial. So you'd always have it as 15, I guess, for the number of trials. And within that, you can always find cases where you have 5 successes. So I mean, I guess like we have a rule that you could blindly follow, which is if you need the 5th success on or before the 15th trial, you can just blindly convert it to a regular binomial with 15 trials and at least 5 successes. That's the rule that will generally work for these problems, I think. For the why that works, I'm still struggling to come up with a very like clean explanation that makes sense to me, but at least there's like the practical guidance for these types of problems. Yeah, Uber, thanks so much for that, because I think it will help me, but I think I just need to let it sink in for me at least. And then SVQ and underscore in here helping out too. Problem is, why can you use binomial of less than 15 trials? I think because I'm still not fully comfortable for myself, but I think the reason is that even though the binomial always goes for 15 trials, you can always find like within those 15 trials where that 5th success happened. I feel like it's weird that we don't have to worry about the rest of the trials after that, which is the probably part that I'm struggling with still, but I think that's the reason why. I haven't fully like come to terms with that yet though. I do want to quickly check this DM, I guess. So hopefully a quick one, and then I should get to what Thunder said. Why did this get locked? Okay, maybe I'll just leave this alone. I mean, I feel like I was... Okay, yeah. I don't know what this means. I don't know why the post is locked, but I'm just going to leave it alone. Let's go look at the one that Critical posted. Critical, are you around? Okay. Bluebird says we could try the opposite. Suppose x is greater than 15, then the 5th success occurs not in the first 15 trials. It'd be fewer than 5 successes in the first 15 trials, so y is less than 5. Oh no, yeah. Even if I moved on to the next question, I still appreciate the explanation there, Bluebird. You can only use comparison tests? Oh god. Oh, it's for 33. Do you recognize the thing inside the parentheses, though? Critical? Actually, I don't know if it's going to be relevant here. E? Okay, good. I don't... It might actually... That might be a coincidence here, but my mind immediately goes to E when I see something like this on the inside. It's only squared, though, which might mean we don't have E, but I think it's a good thing if your mind goes to E with this, even if it's not going to be related here. Let me just look one more time at what Bluebird said, and then we can try these problems. I'm still not sure what I'm figuring out. I'm not sure if that's what we're supposed to do with this problem. I guess I'll figure it out. Yeah. So since it's just squared, it might actually not be related here. But I think it's good to think it's E at first and then realize later it's not, than missing that it is E when it is actually E. If that makes sense. The fifth success occurs not in the first 15 trials. And there have to be fewer than 5 successes in the first 15 trials, so y is less than 5. Yeah, I guess like that case, it makes sense. Like we had that for part D, like a greater than case. And I think Thunder and I are both, like, we both understand this one. I guess doing the flip, it just feels so much weirder. I don't know. So using only comparison tests. So I assume that's regular comparison tests and limit comparison. For 33, I'm not sure exactly what we're going to do yet, but let's talk through and see if we can figure it out. We got sum from n equals 1 to infinity. One plus 1 over n squared times e to the minus n. Okay. This is a good problem. So whenever you're using comparison tests, you need to have some kind of guess for whether this thing converges or diverges. That should be your first step. And this, on the right side, I find this a bit easier to work with. Remember, a negative exponent is the same as flipping the inside. So we could rewrite this as 1 over e to the n. So this piece of the series is a geometric series with r less than 1. So this piece converges. This piece, I'm not quite sure yet. If I got a common denominator, we'd have n over n plus 1 over n squared, which is n plus 1 over n squared. Oh, you know what? That one diverges. I thought it would converge, to be honest. But I'm saying this diverges because we can bring the exponent to the top and to the bottom. And even from here, if you take the limit as n goes to infinity, it's going to be equal to 1. So by the test for divergence, this one piece of it, this isn't the actual proof. This is just me trying to figure out an approach for the problem. This is not the actual answer. But if you pretend the problem is just this one piece, e to the limit as n goes to infinity, this comes out to be 1. So by the test for divergence, this piece of it would diverge. Of course, this isn't what we have. We have a divergent series times a convergent series. 1 plus 1 over n squared is bounded by 4? Maybe individual terms, but if we're summing, I don't think... use a divergence test or comparison test. Yeah, I'm not, even if it's bounded, I don't imagine it's going to converge. I'm not sure how to see where it's bounded by 4, but so I guess with this one, my guess, if we have something that's divergent times something that's convergent, I'm gonna guess, I don't actually know. I'm gonna guess we have divergence, because usually something that diverges is blowing up to infinity, and that tends to dominate whatever else is happening. To be honest, listen, I genuinely don't quite know though. So if it is divergent, and we have to use a comparison, what would we compare it with? Wait, maybe it converges. So I'm having, well, what's happening in my head right now is I'm trying to think of a direct comparison test, or, you know, just the regular comparison test. I'm really struggling to think of a series. I'm struggling, like, I would want to take one part of these series and compare it, but neither parts really help. So I'm struggling to come up with a series to compare it with for the regular comparison test. I think a limit comparison might work. Bounded by 4e to the minus. So how do we know that 1 plus 1 over n squared is bounded by 4? And that would be proving convergence if we can make this comparison. Oh, I guess that's, the answer is converge? Okay. Okay, so I can actually think of a limit comparison test, I think. Let me just make sure that I am remembering the limit comparison test right before I go too crazy. It's not like SPQ has come up with a way to do comparison as well. So we can show both ways, but let me just make sure I'm thinking the limit comparison test right. If it's any finite positive number, okay. I think that's a good thing for the thing that I'm thinking. And I think I understand what SPQ is doing too, so I can explain that approach. Well, is the sum bounded by 2 though, SPQ? The terms are bounded by 2. I don't know if the sum is bounded by 2 though. I don't know if that flies, SPQ. I don't understand it if it does. Because if you have 1 plus 1 over 1, you're already at 2. And if you add another thing on, you're, well, okay. No, yeah, I mean, when it's summation, this just does not work. Because we have to add these two together and we get 7 over 2. I don't think it's a valid comparison that you're making, SPQ, at least, or if it is, I don't understand it. I don't think that the terms being bounded are enough, because we're adding the terms. Okay. But what I do know works is the limit comparison test, and the limit comparison test, I was thinking, we know that this limit on its own comes out to be 1, because we already evaluated this. And we know how just e to the negative n behaves. So let's take a sub n as our initial series, because that's what we need to compare it with. And for b sub n, I'm going to take just e to the negative n. Because we know how e to the negative n behaves, it converges because it's geometric. And when we go to divide a sub n over b sub n, the e to the negative n's are just going to cancel. And we get a limit that we have already evaluated once. So when we set up our limit as n goes to infinity of a sub n over b sub n, we get a cancel, and then we just have the limit as n goes to infinity of 1 plus 1 over n squared, and we showed over here that it's just 1. So you get a positive finite number for your result, which means a sub n and b sub n behave in the same way. So since b sub n converges, a sub n also converges. I was saying positive because that's what Paul's notes said. I don't know why. It has to be positive, but... And I can show the whiteboard again if you... How come the answer is 1? Oh, I should explain that. I kind of glazed over it. So L'Hopital's would work. But yeah, if you're okay with the manipulation going from this down to that, and this is the same thing, let's just continue from that. Because oh shoot, the camera's still on. Hey, Animal Hero? I'm probably mispronouncing that horribly, but welcome in by equivalent. I'm not sure what that part means, but welcome in. So I know this converges to 1 because when I took a calculus class, I was taught that if you have equal degree on top and bottom, you take the leading coefficients. There's many different ways to do limit like this, though. Let me actually expand out the top before I do more talking. So n plus 1 squared is also n squared plus 2n plus 1 over n squared. So the trick that I was taught is that if you have equal degrees on top and bottom, n squared and n squared, then you take the leading coefficients. So 1 and 1. So the limit will be 1 over 1, which is just 1. But there's 2 other ways I'm aware of to do this limit, which you may be supposed to do it that way, because this is kind of a hack. So if you want to use L'Hopital's, that's what you're comfortable with, that's completely valid here. If you try to plug in infinity directly, you do get infinity over infinity, which is indeterminate, so L'Hopital's is allowed to be used here. So let's derive the top and bottom. We'll get 2n plus 2 over 2n. Plug in infinity again, you get infinity over infinity, so we can use L'Hopital's again. Uh, 2n derives to 2. 2 derives to 0. 2n derives to 2. Look at that, the n's went away entirely. 2 over 2 is just 1. The limit of 1 is just 1. So L'Hopital's is valid and gets the same answer. Okay. Um, oh, that's interesting, Luber, because I was wondering how we could use E here in some way. Oh, I guess that's a fourth way to do it with the O notation. I don't know the O notation though, and it's not normally taught in calculus classes, but it's true. Um, oh, you can't do infinite sums in Desmos. Oh yeah, but you can't make it plot it term by term either. Oh, you do X. There. This isn't the cleanest thing, but this thing is not. This sum is not bounded by 4, and bounding the terms is not good enough. So I definitely don't like this bounding it by 4 idea. Anything involving that, because you have to name a sum that's greater than it, unless you want to name 4 times n. I guess. I don't know if that really helps you though, or the sum of 4n. Is it even 4n? I think 4n would work, but yeah, if you do the limit comparison test with that, you would get some version of E, I think. So you could do that idea with E. It might be a bit more complicated than you need, but that I do kind of like that because it gets back to like when I first saw this thing, the first thing I thought was the limit definition of E on the inside. It didn't end up mattering because it's squared. You could force it to be in there if we do Lubert's approach, though. Really? Then I guess I just don't understand what's happening with SPQ's approach. Well, I agree that term by term, it's like that, but I don't think the sum is like that. That was my concern. Like, maybe it is, and I'm just crazy. If I wrote the same thing here, but with oh wait, I guess it would even be like 4. I really the sums it's actually still true. All right, yeah, I mean that's my bad then at SPQ. I guess you're right. Thanks so much for the extra info in Lubird. Yeah, maybe it's I was thinking about it in general, you can't say that the sum is always greater than because of that kind of alternating series case. Maybe that's why I was uncomfortable with that, but in this case where everything is positive, it works okay. That's fair. But nicely done, SPQ. Thanks for being patient with me. zone in Lubert. Everything's positive and there's lower bound by 0. State upper bound is sufficient. Yeah. Yeah, I mean, you can just do, or you don't even have to worry about like a squeeze theorem thing, because if you just use the regular comparison test, I think. Oh, I mean, I guess the comparison test provides that they're greater than they're positive. Okay, never mind. I don't. Am I just the comparison test literally says term by term, and I guess I'm just off today with my comparison test. Yeah, sure, critical. Okay. Yeah, sorry, I'm just like still thinking about that one. Oh yeah, I just kind of hate that I forgot. Like you only need to worry about it term by term, I guess. I'm a little bit annoyed at myself. I'll quickly show SPQ's weights as well because it is a good thing to do. I don't know why I'm just going crazy today. So yeah, we can look at 37 and 39. What is this numbering? I assume it goes off to the right or something. I don't know why it jumped from 33 to 37, but not actually important. Oh wait, why did I erase this? The point that SPQ was making is that looking just at 1 plus 1 over n, it's a form of series that's good to know. If you were to plot it, you kind of start high and you're leveling off and going to 1. So let's say like when n equals 1, you get 1 plus 1 over 1 is 2. When n equals 2, you get 1 plus 1/2 is 3 over 2, so you're a little bit less. When n equals 3, it's 1 plus 1/3, and you're getting very close to 1 from above. Just say a sub n equals 1 or something. It's not actually a sub n, but this is like, it's just a nice form to know whenever you see it for a sequence, or this is just the actual terms, I guess, not the actual sum. But the point of the comparison test is that you can find terms that are, if you can bound the terms, you can bound their sums. So we gotta say this is bounded above by 2. I kind of want to take away the a sub n part entirely. And again, this is talking about the sequence, not the actual series, but that's good enough for the comparison test. And so if we can make the claim that 1 plus 1 over n is less than or equal to 2, we can also square each side and make the claim that 1 plus 1 over n squared is less than or equal to 4. So the comparison test way to do this, if you prefer it, is to compare it with 4e to the minus n, because you know this 4 piece is bigger than that 1 plus 1 over n squared. And then you can, you call that a geometric series and show that it converges. So I just want to show why that approach is right too. I didn't think to. I guess with this type of series, or when I see that, I don't always think to do a comparison with it, but it's valid. So anyway, we can move on to your next one though. Doing only odd problems. Oh yeah, no, but there's still no like 35. So it's not important though, because it matters of the actual problem, but let's look at your next one. We got n equals 1 to infinity sine of 1 over n. Ooh. That, I don't know what this is going to be. These are some hard ones, which I kind of like. Like I just did the comparison test. Oh, okay. 37 not converges. Will it? I think you can compare this with a geometric series. So what I'm thinking here, sine of 1 over... So if we think about the actual function, sine of 1 over x, this is like a really special function. It has super weird behavior. And like this part is probably a little more information than we need, but like when it's close to 0, it's actually an interesting function, like to graph in Desmos. It's a really erratic thing. Like the closer you are to 0, the quicker up and down it goes, and then the farther away from 0, it kind of spreads way out. And I think eventually the important bit is it levels off and just kind of stays right above 0. And I think for that reason, there's going to be some kind of geometric or maybe even p-series that we can compare with it. Because we're thinking about as n goes to infinity here, we still have our good old upper and lower limits of 1, no matter what. Let me verify that like tail part, because I think it does stop fluctuating after a certain point. It clearly diverges? Oh god. It approaches 1 over n for large n. To me, the divergence isn't clear, but apparently I'm terrible at math, so don't trust me. Let me just verify this sine x, 1 over x thing. Okay, yeah. So the computer test is 1 over n. Oh, that's the clever zone. Okay, that's fair. Because yeah, Animal, I think your comparison test, that inequality goes the wrong way. But this is also just like a neat function to look at in Desmos. No matter how much you zoom in on this middle bit, like it never, like, it's just like a wall. So it's fluctuating more and more the closer you get to 0. It's kind of a fun function. But we're going as n goes to infinity, which means we're going far out to the right, so we really care about this like piece on the tail. But it's kind of a fun function in general to like look at. I think zone is just giving us the right answer here, which I appreciate. Which we want to do limit comparison tests. I can't think of a helpful comparison. And Milk is saying basically the same idea. So if we're gonna do limit comparison, as usual, name our A sub n as just the original series. And this is something that's really hard to spot. I don't know if I would have spotted this without Zone Ranger and Milk pointing it out. Oh, wait. Okay. Our B sub n is going to be 1 over n. And the idea, kind of like, the thing that I was trying to figure out is that this piece at the end, as it trails off, it looks a lot like some function like that, which 1 over n is. There's also like, it also looks to me like a geometric sequence, which is why I was thinking that there would be some comparison there. But we want 1 over n because we're going to get a special limit here. Yeah, this one it's hard to see unless you know what the result is already. So let's work through it and then we can explain it more as we go for why we're choosing 1 over n as b sub n. So if we set up our good old limit comparison test, we do sine of 1 over n over 1 over n. Now for this next part, I'm not sure what the best way to explain it is. What I want to do is to change your variables here. I don't know if there's a better way that would be more in line with what you're learning in class, though. I'll check chat and then I'll do the change of variables way, I think. So I don't see a better way to do it here. How come b sub n? Yeah, tired student, we're still on this. Taylor series? I don't know if Critical's gone to Taylor series yet. I don't think so. Do I need to eliminate sign and treat it as 0 or 1? No. Wait, so we are using limit comparison here, but actually evaluating this limit is actually, I mean, you technically could do a Taylor series, I think. Well, I don't know. I've heard conflicting reports on that, but I'll just do it the way that I'm thinking, and hopefully it's not too absolutely crazy for what you learned in class, critical. So I'm going to make a change of variables here. I'm going to say it's just like a u sub with integrals. You're allowed to do substitutions in any problem anytime. It's just that students often encounter it for the first time with integration, but we can do a change of variables here. I'm going to name x equal to 1 over n. And when we change our variables in a limit, we have to think about if n is approaching infinity, that means x is approaching 0 because x is 1 over that. And then we get sine of x over x. And this is why we chose 1 over n for b sub n, because the limit as x goes to 0 of sine of x over x is a special limit in the exact same way that e is a special limit. I think I got that right. In the same way, you're supposed to know that this limit comes out to be e, you're supposed to know that this limit comes out to be 1. Oh, no one got first? Well, it's all you then, Shep. So we get 1 for the result of the limit, which means 1 over n and sine of 1 over n behave the same way. And 1 over n is a harmonic series which diverges, so sine of 1 over n also diverges. But the reason that Zone suggested 1 over n is because Zone knew that we would get this special limit with sine x over x. And the x's I just like chose randomly. You could use any letter you want, but if you don't remember this sine x over x thing, or if I didn't remember, I would have a lot more trouble with this problem. I don't know if there's a different way that you could even do this, possibly. Yeah, I can't think of a regular comparison that would work here, or a different limit comparison. So that one's a very tricky problem, I would say. Time for some chem? You convert 1 over x, 1 over n is x, then make it 1. Yeah, critical. We're making a change of variables, which is completely valid. That means we do have to change what the actual limit is, because if n gets very big, x is getting very small. Yeah, this one, like, this is like a challenge problem. I would say this isn't. These first two problems have been very different from the ones that we've been doing before. So I wouldn't feel bad if you're having problems with them, because I also am having problems with them too. So someone's just. These are just like difficult ones. Milk is saying 39 is gonna be the same trick. How do I interpret this in comparison test? For regular comparison test, I don't know. I can't think of a comparison test that's valid here. The only comparison test doing this exact choice is the only thing that I can think of to prove this limit so far. Yeah, I can't think of another way to do this, unfortunately. Critical. Another cat, Shep? I just drew a cat, though. Oh. You want the limit comparison test way? I mean, or rather, like how to interpret the limit comparison? Because I kind of like glazed over, but like if you want to know like how you make the conclusion with limit comparison test, I can explain that more. If you're asking about how to do just the comparison test, I'm not sure. But this was limit comparison test, and since the result of the limit is positive and finite, that means that these two series behave the same way. If we got 0 or if we got infinity or something weird, then this test isn't valid. But if it's any positive and finite number, then these must behave the same way. Yeah. Okay. Hey, Obehe, how's it going? Okay, yeah, and we can move on to 39 now. So we have n equals 1 to infinity, 1 over n tan 1 over n. You had a question on limits that had you almost explained. Oh yeah, Obehe, if you have a question, type it out in chat there, or put it in my Discord. You might already be in my... I feel like I remember having a question from you before. But yeah, feel free to let me know. And Obi, hey, thanks so much for the well wishes. The notable product of E. Oh, like the limit definition of E? We can talk about that. Let me work through this problem here on the board. You'll put it on the Discord? Okay, sounds good. Yeah, once we get through this limit on the board, we can talk about yours. And then we'll go back to critical unless someone else has a question. So milk, we get 1 over n squared and converge. You're saying to do limit comparison with 1 over n squared? This one, I have no clue what it looks like. Yeah, this is like I'm trying to imagine this function in my head, and I'm not sure really how that's going to behave for large values of n. Tan and sine are same thing for large n. Really? Tangent is sine over cosine. Oh. So, wait, for large. Oh, yes. Okay, so okay, so as the point that Milk is making here is that as n gets very large, which is what we're concerned with because n goes out to infinity, as n gets very large, the thing we're inputting into tangent is getting very close to 0 because 1 over infinity is 0. So we're talking about very small numbers here. And if tangent is sine over cosine, cosine of a very small number is approaching 1. And if you divide by 1, you're not doing very much at all. So that's really clever. So it means we get to worry more about tangent being just like sine for a very small input, which is what we have here. Wow. So we do have a difference from the last problem, which is we have a 1 over n extra out front. And that 1 over n is serving to make it decrease even faster, like but before the sine of 1 over n, it ended like that. But if you stick a 1 over n, if you multiply by 1 over n, 1 over n for a large n is a very small number. If you multiply a very small number, you decrease it. So sine of 1 over n was like that. 1 over n times sine over n is going to be even less. So because it's going to be less, we can suspect this one might converge instead, whereas the last one diverged. At least has a better chance to converge. And we can find that we get a nice cancellation 1 over n squared, which I don't know if I would have spotted that without Milk's help. But A sum is going to be our usual initial series, B sum is going to be 1 over n squared. And we're going to do limit comparison again. I have a very hard time explaining this if you're someone who's approaching it blind. Like, if you gave me this problem on my own, I don't know that I would have solved it, to be fair. So that's kind of, I'm struggling to give you an explanation that's from that perspective, which is why I keep hesitating here. But I think with these tricky ones, you kind of have to see the tricks a lot. Before you spot them for yourself. So, I mean, how are we even going to evaluate this limit? I guess L'Hopital is applicable here. I think. So do we even want L'Hopitals? I'm expecting that we're going to get 1 as a result for the limit here, but I'm kind of struggling with it. We can cancel 1 over n with a 1 over n squared. I'm debating if we want to do another change of variables, like in that last problem. In terms of sine and cosine. Really? Sine 1 over n over I guess this 1 over n could come up top. I'm keeping it down here because I feel like it might be helpful later on in the problem. I'm not really sure though. And so are we going to split this limit up is where zone is going with this maybe? Because this is going to be the same special limit that we just did. And if we can figure out what this limit is, did I do a good thing there? I don't know if I did. I don't know if that's good, but I just did. Isn't 1 over cosine 1 over n as n goes to infinity? Isn't that going to be infinity? I don't know if I did the right next step. Oh wait, cosine of 0 is just 1. Never mind. And hello to Fraster Leaf over on YouTube. Been struggling with N3 maths with very basic multiplication, like 5 times 2.3. Any valuable suggestions to improve? Or sorry, Fraser Leaf. I yeah, I have multiple people who are asking questions, so I can only, you know, help out some people at a time. But Fraser Leaf, if you want to get good at multiplication, the unfortunate answer is you just have to do it a bunch. With most things in math, that's kind of the unfortunate reality as far as I know. But yeah, so I was making this limit too complicated in my head, or I was making this limit more complicated than it has to be. By the problem we just did, we know this limit is 1. Over here, if you can just plug in infinity here. So 1 over infinity is 0, cosine of 0 is just 1. So the limit of 1 over 1 as n goes to infinity is just 1, so you get 1. So then the limit comparison test applies since we got something that's positive and finite. So these two series behave in the same way. 1 over n squared is a p-series that converges. So that means 1 over n tangent 1 over n also converges. I'm Razor, I'm not laughing at you. I'm laughing because I'm trying to figure out how to explain that I'm currently working on a math question, and putting more and more question marks in chat isn't going to help you out. I was trying not to tell you that directly to be more polite, but like, I'm clearly in the middle of explaining something else, and I'm just going to drop the thing that I'm currently doing to help you. I will try to help you as soon as I can, but SPQ, you're saying L'Hopital shouldn't be used if possible? I'm kind of interested to hear why. Invest in a calculator? Yeah. I have a question. Do all the non-trivial roots have real part 1/2? Like roots of a polynomial? Or if I'm not sure exactly what you're asking with there, Fraser. Yeah, you just plug infinity right in there. Yeah, so if you're getting complex roots for a polynomial, it's not always 1/2 for the real part. You probably get that like kind of commonly, but it does not have to be that. You posted more questions? Ask me to prove the Riemann conjecture? I don't know, Milk. L'Hopital's unsightly. Oh, okay, that's why, SPQ. All right, I forget who all helped me there. Even Zone pulled the word clearly on me before. Zone did help out a lot with these. Milk did as well. Also, hi, Zach. Sorry, I was reading a question. I don't know if I actually said hi to you, though. And sorry, Animal, you put a message in before, and I wasn't able to address it. Oh, it's kind of an interesting approach. I said hi to Obi. Okay, hopefully I'm caught up with chat. I'm sorry if I missed anyone's message. It's hard to juggle this many like things right now. Okay, so your bear's exactly in time with the music? It kind of is, yeah. Okay. So critical, I'm gonna come back to you later because Oveja asked a question. And then I'll come back to you. So I think there's something else in queue after Oveja. So Oveja, if you're still here, I'm gonna bring up your question now. It's on Discord? Okay. Okay, yeah, so we're talking about the limit definition of E here. Let me scroll up and see what you were asking about before. Okay, well, you're just kind of asking like what it is, or the upper part about explaining it when this book doesn't have solved exercises. You want to see if you were doing it right. The exercises solve are the two down. Okay, so you want me to check your work on the exercises here? Like the most down. Oh, so you have to evaluate these two things here? So there are two exercises and you solved it, you think you might have done it wrongly. Okay. So yeah, I'd say for this first one, you have the limit as n goes to infinity of 1 plus 2 over n to the n. So here, I would just use, they give you a formula right here, x equals 2, and you have a 2 right there. So I'd say the answer to this first one is e squared, or, e to the power of 2. Is that what you got for that one? E squared, good, okay. Now the second one, it's a little bit harder. We have the limit as n goes to infinity of 1 plus 2 over n squared plus 1 to the n. How do we deal with this n squared plus 1? It looks like they gave us a hint over here. Oh. Interesting. I haven't seen this approach before. I do kind of like it, though, the more I look at it. I'm just working on my head how this is going to work. Something like 2n over n squared plus 1. You can't cancel there. Right, you are not able to cancel there. I agree with that setup. That's what I have going on in my head. So let's write this out. I think this limit is going to end up going to 0, and we can figure out why together. Okay, 1 plus 2 over n squared plus 1 to the n. Okay, so now if we use the approach that's from your screenshot there, we would set up e to the power of the limit as n goes to infinity of this piece times the exponent, which I kind of like as a way to approach these problems. Because I don't have a good way to approach these, so I like seeing this. And so that matches what you said. That we get e to the limit as n goes to infinity of 2 times n over n squared plus 1. So how we evaluate that limit up in the exponent, infinite looks like 8. Yeah, I know, I'm bad at drawing infinity. Hopefully it's readable enough. So when we evaluate this limit, it gets taught in different ways. The way that I was taught is that the degree on bottom is n squared. So the degree on bottom is 2 because it's n squared. The degree on top is 1 because it's just n. So the degree on the bottom is bigger because the degree is bigger. So if the bottom is very big, that means that you're approaching 0. But there's no way to do that that kind of shows it a bit better than just like something you have to memorize. So what I'm going to do here is I'm going to factor, if we have an n on top, I'm going to factor an n out of the bottom here. And I think this should give us what we want. I hope it does. Or should we do n squared? I lied. I'm going to factor an n squared out of the bottom. It's going to look weird, but it'll make it a bit more clear how to evaluate the limit. So n squared times 1 plus 1 over n squared. So all I did was take an n squared out of the bottom here. You're more disappointed by the physics? The higher grade thing? Yeah. So it sometimes gets taught as a rule, and this is why that rule works. But yeah, the exponent here is bigger, so this part is more important on the bottom. So if you just want something to memorize, that's kind of like the rule for that. But to actually show it, it's just basically one more step after this. So we factored an n out from the bottom, and let's cancel the n with the n squared. So we get e to the limit as n goes to infinity of just 2 over n times 1 plus 1 over n squared. And this is a helpful step because if we plug in infinity now, then it'll be more clear what's happening. So we get 2 over, oh shoot, I'm sorry. I'm gonna actually plug it infinity in. I don't know if this is really good form, but I'm just gonna actually, I think it's more clear if I write infinity inside here. So we get 2 over infinity times 1 plus 1 over infinity squared. So this technically, like, this kind of hurts me to use infinity as a number like this, but just to like demonstrate what's happening here. Infinity squared is just infinity because if you square infinity, it's still infinity. 1 over infinity is 0. So we really get 1 plus 0 on the bottom there. Infinity times 1 is just infinity, so 2 over infinity. And so when you divide by infinity, you just get 0. So I'd say this is e to the 0, which is just 1. So I hope that makes sense. Are you disappointed by... Oh, you're disappointed about me not drawing a cat? Yeah, there's too many actual math questions happening right now, Shep. Awesome, Ovehe. You had this since like 3 hours ago? That's kind of painful, but I'm glad I was able to help you out. Let me know if you run into anything else. The reading group of physics. Oh, yeah, no, well, yeah, you're disappointed in me for multiple reasons, I guess. Oops. Thank you for the question. All right, so we can go back around to criticals. I don't think anyone else posted a question. Oh God, what are these? Oh no, okay. You're still here? Okay. A mitotoxin again? Oh no, Shep. I remember you made me draw that before. We can keep the Desmos open. So critical for these, are you similarly limited to just comparison and limit comparison? Hey, Mincha. Maybe you could help me. Can you explain how to parameterize a curve in polar coordinates when the curve is a straight line? How would you do that? I know how to do a vertical or a horizontal line, but for any line... Oh, yeah. Well, wait. Yeah, just the line is theta equals the angle of that line. Alternating and absolute convergence series. You wish you could donate? Yeah. Okay, so mention to just come in the YouTube chat and ask a question here. I'm sorry, Kurt, but let me work on mentions first, and it sounds like there's going to be even more, or there's going to be like a lot from you. So I believe I haven't done this in a little bit, Mencha, but I think we have 3 different situations to worry about. If you want to convert a line into polar coordinates, if you're given a vertical line like x equals 3, you just use the conversion formula for x, which is x equals r cosine theta. So you convert x equals 3 by just saying 3 equals r cosine theta, because that x equals 3, and then you can solve that for r, I think is how it's commonly done. So you'd say r equals 3 over cosine theta. That's another thing for a horizontal line. If you have y equals 2, you use y equals r sine theta. And so you say 2 equals r sine theta. And then you solve it for r, you get r equals 2 over sine theta. But I assume what you're asking about is a more complicated line, like y equals 3x plus 1, which we can also convert to polar, but it's in a bit of a different way. It's a curved parameterized. Oh, okay. All right, bye, Shep. Sleep well. Okay, so a curved parameterization in time. Thank you for clarifying that. You have a problem finding the angles. I guess we knew about finding the angles. So it's like, there's that's about a general converting function into polar, and maybe I'm still misinterpreting you, but we kind of have the general conversion formulas. I guess like, are you asking about like how to apply these formulas? Wait, I got that backwards. We're asking about something that's a bit more complex. Example, y equals x plus 2. Okay, so if you ask about y equals x plus 2, we can definitely do that example. So the so yeah, so it is. I was interpreting you kind of correctly, just a little bit too like broadly. Like you want to know how to like convert this line into polar rather than a vertical or horizontal line, which we can definitely help with. MR solve for R. I like that. Milk, yeah. Let's do it that way. So if you want to convert this into polar, it's basically going to be a mix of these two. I would still use our same x equals r cosine. r sine theta. For y, I would still use these two formulas here and plug them both in for y and x. And then we'll do some manipulations after. So y, we said, is r sine theta. X, we said, is r cosine theta. And then the plus 2 is still just plus 2. Now I would take this and solve it for r, because that's how polar curves are normally given. So I'm going to subtract the r cosine theta to the other side. Equals 2. Just check chat to make sure I'm not going too far off the rails. And p of a in this case is minus 2 sine I'm getting something slightly different, I think, Mencha. So I'm not sure what the difference is going to be here, but let me just follow this through and then we can see if we're getting the same thing. From this, I'm going to factor out an r. So we get r sine theta minus cosine theta equals 2. And then I'm going to, we have r isolated, we just need to divide over the sine theta minus cosine theta. So let's do that. So I get r equals 2 over sine theta minus cosine theta. And it sounds like you're using rho and a, which I haven't seen before, but we can do. I just assume it's rho, and you're just writing p. And maybe that theta is alpha rather than a. But the letters aren't the important part. So we are off by a negative sign, aren't we? R2 answered. I'm not sure why that would be. Minus 2 over sine a cosine a. Oh, okay. That explains it. So yeah, if it's minus 2, then we will match exactly. Okay, so I hope that explanation makes a bit more sense then. No, you're good, Mencha. Don't you have any questions on that? How do you calculate RO? I assume it's in like the Greek letter rho. It's what I showed on the board. I can switch my R to use rho so it matches your work. But that's what I did here. The way that I learned, I used R, but if I use rho and alpha to match your work, I'll rewrite it so hopefully it looks a bit cleaner for you. So I'm going to say y is equal to rho sine alpha and x equal to rho cosine alpha minus 2. This becomes an algebra problem of just isolating rho. So subtract over the rho cosine alpha. And then we factor the rho out of these two terms. And now we nearly have rho isolated, but we need to divide over the sine alpha minus cosine alpha. So divide each side by that. And then you get the desired answer. I hope that makes sense. You mean the angle? The curve starts on minus infinity to 1, negative 1. I'm not sure what you're asking, Mensha, I guess. From minus infinity to 1, negative 1? Yeah, I'm not sure what that means. Yeah, I have a Discord, if it helps to post a screenshot. Get a sip of water while we wait. I hate it when Discord does that. It's not letting you accept it. These invite links are so annoying for that. Because on my end, the Discord link still works, and I think it just likes to tell you that the invite isn't always valid. Shoot, I'm not sure. Like, if you want, you can add me directly, I guess. How do I get? Isn't there a way? There we go. Copy. If you want, you can try DMing it to me. Oh yeah, there's no like numbers on Discord names now. Critical. Do you have to leave soon or something? Oh, it seemed like it worked. You were kind of wait. The link works. Okay. Thanks for. Yeah, I think it's just a. It's a weird Discord thing where I've had it before where like I try to click on someone's Discord link and it just doesn't work, and I don't know why. You were kind of away. Okay. Yeah, critical. So I'm trying to work through Mencha's thing. Although it sounds like my Discord username. Just want to add me directly. But if it's going to be a second before we can understand Mencha's problem, we might try and sneak one of yours in. Okay. Oh yeah, sure. I'll at you in the chat. Let me get that harm off the screen for now, because I think it's going to be a different problem. Oh, and thanks for the follow as well. All right, I guess if you want, you could like upload it to like an image, like hosting site, and put the link in. I think Twitch chat the YouTube chat would probably delete it. If Discord is easier, then like I do whatever's easiest for you, I guess, and I can make it work. Can you DM me here? Sure, I can try and send you a whisper. I whisper so rarely. Can I do it by clicking on your name? Apparently not. Frickin' Twitch. Okay, mention 1899. Inch 1899. Hi. Okay. I whispered you if you want to. I could send a link through that, or I'm not sure what's best for you, but. Oh, you're able to get into the Discord. Okay, cool. Good, good, good. Let me bring this up on the screen. Oh, I see why. Okay, this is this is a little more complicated than just a straight line. I see why it'd be hard to describe this in text. Um, using the polar equation and Scribir parameterization. I think I'm gonna need to translate this, which is okay. Now is Google Translate gonna cooperate for once in its life? Oh, hey, it actually will. Find the parameterization of the curve shown in the following figure. Indicate the expressions in the intervals of the parameter. P equals -3, √3. This is requested in 2 ways? What? Oh, so it ends at this Cartesian point P. Yeah, this is some weird piecewise thing, it looks like. Like, I hope this curved part here is a circle. No, it's an ellipse. No, it's a circle. Okay. I mean, unless it's, the scale is weird, but... Huh. Find the parameterization of the curve in the following figure. Indicate the expression in the intervals of the parameter. You remember seeing that exact graph Tired Soon says? Yes, it is a circle? Okay. Huh. I guess the parameter is theta. Or alpha. What Greek letter? B. Okay. Tired Student, Google Translate has an image translation thing. If you just go to Google Translate, there's like an image tab. This supposed to be -3, 3 √3. Oh! 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. 3 √3. Yeah, Femvox, that's a good point. P, that is, root 3 is 1 point something. This P is way too high for the Y value, it seems. Huh. What is 3 square root 3? 5.19? Yeah, so it probably is. Actually, was that a Google translation issue? No. Okay, so I think there's already a potential issue in the question here where they say P is -3 comma root 3, but this graph, the P here is not -3 root 3. That's like 3 root 3, probably. That part is illustrated, the value changed. Oh, really? Okay. Huh. This is requested in 2 ways. Judging by the image, it's supposed to be a straight line. I think it's like some piecewise thing where you have a straight line, a circle, and then another straight line. We're gonna have to define this pair like in a piecewise way. They recycle exercises? Okay. Which one is the real one? Like, should we go off only the graph here? Ignore the graphic value? Okay. So I assume then we're starting at 1, 1, and then ending at -3 root 3 somewhere over here instead. Okay, this is a very weird one. I guess we can do it. So I think problem is for the, yeah, like the one down here. So I guess we need the polar equation for this lower line, the polar equation for this circle, and the polar equation for this line here, but really this point P is not the point that's depicted on the graph. Okay. That's how I'm interpreting this, at least. Okay. No, let's stick with green. No, let's do red. I'm going to draw my own version of the graph here. And that point right there is negative, or 0, -2. Okay, so I guess let's split this curve up into 3 bits. When it tends to -infinity. Oh. Oh, really? We only have to do this piece here? That simplifies it a little bit. We only have to do one thing. which is nice. So yeah, if we're only focusing on like this line down here, that would be with like the negative of infinity for our parameterization. So if you have 2 points, do you know how to calculate a line, or do you want to see that part of it too? That's just the part you're having issues. Oh, okay. So I would first figure out the Cartesian equation for this line. Actually, you already said it's x minus 2, right? So you already got that far. I agree with that. Okay, yeah, good. Okay. And so I would do our same thing that we just showed, but maybe it's the interval part that you wanted to see. So I'm going to say that our conversion formulas are y equals rho sine phi and x equals rho cosine phi to match the variables that you're using. So y is rho sine phi, x is rho cosine phi, minus 2. Now let's solve this for rho. So subtract the rho cosine over. And we do get the same result in this part, so maybe I shouldn't spend that much more time on it. So actually, you already got to the same result here, so let me not go over stuff that you already know how to do. So you got this, but you want to know the interval part? Okay, right, yeah. So how do we find the angle? That's what you said before. Okay, I think I understand the question now. So how do we express the angle that's happening for this section? Okay. Now I understand what's happening. Thank you for... Okay, perfect. You already have one part of the interval. We know that rho is going to go as far as minus pi over 4. But we need the lower bound for it as well. And I think our lower bound... Oops, I'm sorry, minus pi over 4. Because that's the negative 1, 1 there. I think our lower bound, I think we're going to be allowed to put any angle in here all the way around to negative pi. Let's make sure, does negative pi exactly work? Sine of pi, or of negative pi, is 0. Cosine of negative pi is negative 1. But there's a negative sign in front, so it becomes positive 1. So yeah, I think we get a valid answer. Like, we're not dividing by 0. So I think we're allowed to plug in anything we want in this quadrant. And this quadrant is minus pi over 2 to minus pi. I think that's the lower bound there. Or is it though? Because the actual, maybe it's not. Huh. No, that's kind of, this is messing with my brain. It's like we have to figure out, like, does this line go on forever, or does it actually start? Huh. Yeah, it doesn't feel right the more I think about it. Like, is it really, maybe it's supposed to be the angle, like, from here to the line. That's a terrible straight line, but the thing is, if this line goes off forever, how do we get that? I think what I need here, I want to play around in Decimos maybe. Yeah, it goes forever. We start with -3 pi over 4. Really? So if it goes forever, we start. SPQ over in the Twitch chat is saying that it should be strictly less than -3 pi over 4. I'm not sure I understand why, but is it because we're going to be starting to divide by 0 by then? Oh, I think I get it. I don't know how to... So I think the important bit is that at -3 pi over 4, on the unit circle, that's sine and cosine are equal there, right? -√2 over 2 minus √2 over 2. So actually, -3 pi over 4 is a discontinuity because you're going to divide by 0 there. That's the key. So if the line goes forever, this number in the bottom is going to be very small as we get closer to -3 pi over 4. And that's how you can justify the line goes on forever. So we never go exactly to -3 pi over 4, but the closer we get, like, that's how you can justify that the line goes on forever. Because sine and cosine are equal to each other there. Yeah, it's an asymptote, exactly. Nice call, SPQ. The line is at an angle of -3 pi over 4. Yeah, that's a nice way of thinking about it. Or to like to figure that out, just making the y intercept 0. But yeah, mentioned theta equals 3 pi, -3 pi over 4 is an asymptote. Messed it up. So I just grabbed it in polar here. We can make the upper limit -pi over 4. And the lower limit, maybe like -pi, for instance. Oh, because it's periodic. There we go. So yeah, that's kind of funny. Exactly at 3 pi over 4, we're dividing by 0. But the closer you get to -3 pi over 4, the farther down you go this line, like infinitely. Oops. So I hope that like kind of asymptote way makes sense. And I guess the function just isn't defined between, like, what would that be? 3 pi over 4 and 5 pi over 4? Like for that, like for like this bit over here. I guess is okay. Or I don't know what the upper bound would be 3 pi over 4, but whatever. Or like this upper part, but so yeah, mention. Let me know if you have any questions beyond that, or if there's something that like that doesn't make sense still. If not, I'm gonna move on though. You understood? Awesome. Well, thanks so much for the question. I'm glad I was able to help. And if you ever need help in the future, there's other math streamers over on Twitch. I'm not aware of any on YouTube, but if you ever need more help and I'm not around, there are streamers out there on Twitch. So there's a whole list of them there. But you don't have to do anything you don't want. I just like to shout them out whenever there's someone new around. All right, so let's take a look over at critical. Problems there. No problem. Okay. 5 minutes? Yeah, sure. Are there any besides you teach math here? Oh yeah. Oveja. I really need to look into it to see people do it on YouTube. I haven't looked very hard and I feel like I should. But over on Twitch, there's a whole little community of people who do like math help. Oh, and you know what? It seems like the both of you might speak Spanish, and there's a Spanish language math streamer on Twitch as well. Let me get the link. If I can find it. There we go. So if there's a Spanish-speaking Twitch streamer as well there. I know that Critical isn't going to be here for a couple of minutes. Yeah, no worries, Oveja. I want to get a head start on this though, so I can try and figure out what's happening with these series, because all of these look a little nasty. Alternating and absolute convergence. So for this one, I guess, yeah, Critical mentioned where it's going to be using absolute convergence. So I think we'll be able to compare this first one. Oh, no. Root and divergence, doesn't it? Yeah, I don't know. How are we gonna do 15? Alternating series and absolute convergence series. Um, I don't know if we have to use specific tests here. Critical says it involves alternating series and absolute convergence. So I think we're gonna consider the absolute value, at least of this series. I haven't even thought about the other ones yet. Oh yeah, I think I remember maybe talking about that flowchart before. I mean, it might come in handy here. Still have a link handy. My instinct is to compare it with 1 over root n, but that's not a helpful comparison. It might be another limit comparison. It might be like that other problem involving sign. Comparing with 1 over root n? No, but then that limit... if you do a limit comparison with 1 over root n, you're going to get sine of infinity, and who knows what that is. No, Critical, you're completely fine. I'm not sure even have to, I'm not even sure how to do 15 here. Sine of n plus a half is tricky, yeah. Like, I've been thinking this entire time how to do 15, and I don't have a good way yet. It's not quite precise. 3 terms positive to 3 terms negative. Oh, yeah, I guess there's gonna be some kind of like offset, like eventually it's gonna become wrong or something. Hmm. I assume this is gonna, I feel like it's gonna diverge. That's a complete, like, guess though. We can, I kind of want to graph this one. We know it doesn't? Really? It's converge. Interesting. Oh, because I did that. Okay, that looks convergent. Huh. Yeah, what's the question? Use alternating series or absolute convergence? I think absolute convergence. I don't think alternating series is cleanly applicable here. Yeah, like these two down here, my first instinct is going to be alternating series. But this one, it's not really a clean -1 to the n. The sign does fluctuate, but it's not exactly clear to me what's happening with that. Hey, Nick, guess who's studying for math again? Glad to have you here. Oh, you're saying, SPQ was saying it doesn't, where the sine of n plus a half approaches 0. Phobos, I'm interpreting the pi as outside the sine. That would give you a nice identity though with cosine, right? I imagine they would have been more specific if the pi wasn't inside the sine though. That is a little bit unclear, I guess. And I'm going to sum from n equals infinity to 0. There we go. Why would they write the pi at the end though if it wasn't inside? You know what? That's super weird, Phobos. You're right. That didn't even cross my mind. But why would the pi be on the right side if it wasn't inside the sine? If it's a coefficient, wouldn't it be over there? Because I was interpreting the same thing as this, which is much more clear to me what's happening. But if the pi is over there, are they using bad notation or? Well, I'm just gonna call it bad notation because I think this is ambiguous. It probably shouldn't affect the value of the limit though. Yeah, well, let's graph the other version too, and if the answers come out to be the same, then we can maybe cover our bases either way. I assume it's going to converge, it's getting closer together. That's... the more I look at it, the more I think the pi is inside the sine. If the pi is outside the sine, this is a really hard problem. And I gotta think, since they wrote the pi on the right side, that it is inside the sine. It's so unclear to me. But if it's not, I have no clue how you solve this series. Hey, random dude over on YouTube. I think I can do that problem. I'm going to work through problem 15 on the screen here first. Z squared equals 1 plus 2i. I've already started doing 15 here, so I want to keep on doing that, but I can get to you right after, that's okay. Oh, yeah, get rid of that, get rid of that. Okay, yeah, so critical. I'm going to interpret the pi as being inside the sine. I feel like that's how the book intends it. So rather than that, I'm saying this. So I genuinely have no idea how you do it if the pi is not inside the sine. And I feel like this is a lot more in the spirit of what the other questions are asking. So if you multiply the pi inside here, you get pi n plus pi over 2. Well, I don't, do I even need to multiply that? I mean, okay, I think we just need to think about like what n is and how it's gonna affect things. So if n is 1, we get sine of 3 pi over 2, which is -1. So just thinking separately about only that piece. N 1, 2, 3, 4. N pi plus pi over 2. Just gonna make a quick like. That's I don't even like what I did there. So if n equals 1, you get sine of 3 pi over 2. Sine of 3 pi over 2 is -1. If n equals 2, you get 2 pi plus pi over 2. Oh. 2 pi plus pi over 2. What is that? 5 pi over 2. Isn't that just like, no, 2 pi plus pi over 2 is just like pi over 2. Ugh, I'm making it too complicated. Sine of pi over 2 is +1. If you plug in n equals 3, you get 3 pi plus pi over 2, which is like 3 pi over 2. Okay, yeah, so it's gonna alternate. So we can say, if we're starting from n equals 0, we can say that this is doing the exact same thing as -1 to a power involving n. We need to make sure that our first term when n equals 0 comes out to be -1. If n equals 0 here, we get +1. So let's add 1 to make sure that it matches. So I'd say these two things are completely equivalent because sine of this is always -1 or 1, and we matched like our starting term. Random dude, I told you that I'm going to get to it after this problem. You don't need to spam it a million times. Like, is my mic muted or something? And from here, we can apply the alternating series test. So we can just take limit as n goes to infinity. And this is just going to come out to be 0. So since this came out to be 0 by the alternating series test, I'd say the original thing converges. Yeah, the alternating series test is really nice. I'm gonna look it up to make sure I'm not missing a subtlety here, but I'm pretty sure the alternating series test is just that quick. Yeah, it is decreasing, and the limit goes to 0. So we'd say that it's convergent. All right, random dude, if you're still here, I can look at your complex number problem now. But, you know, like I already said, I'm going to get to you after the problem that I'm currently working on. I feel like it's not unreasonable. Actually, let me hear something from you, random dude. So you just left, and I'm not gonna bother. But if you say anything in chat, I'll go and do your problem. But now I'm gonna keep working out on criticals. I'm not saying anything from random dude yet. I'm going to start looking at 17. Okay, for once, I know how to do this one off the bat. This is going to be another alternating series test. Oh, wait. Yes. So, checking the conditions of the alternating series test. This is another... you have to deal with them on a case-by-case basis. There isn't a universal thing, unfortunately. So like for the one up here, we had to mess around with it and think about what the actual values are. For this one, we looked at sine of 1 over n before, so sine of pi over n is going to be nearly the same thing. Sine of pi over n. So, even though it's fluctuating over here, no, it won't be 1. I'll explain more why in a second. But for the alternating series test, we want it to be, we want the non-alternating version to be decreasing, and we want the limit to be 0 as n goes to infinity. So for the decreasing bit, even though this initial part is fluctuating, we only care that in the long run it's decreasing. Oh, that's a good question. Sorry. For the way the site, it gets phrased differently. The b sub n that they're using here is just the non-alternating part. Like if you remove the -1 to the n part, that's what your b sub n is. So I'm treating b sub n as just the sine of pi over n part. Yeah, sorry, that's an important distinction. So just sine of pi over n, in the long run, it starts high and it decreases. This part before, we don't really care about. You ask a good question, because that's actually, I'm kind of glazing over a little bit here. So we have kind of two alternating pieces, which is the part that I wasn't really addressing. The -1 is alternating and the sine is alternating as well, which is kind of funny. That's why I'm laughing. We won't need squeeze theorem here. When we're alternating, I prefer to use the alternating series test anytime I can, because it's so like short, like that other problem. There probably is some squeeze theorem or comparison test type thing that you could do here. Actually, yeah, I mean, you could show us... Actually, by the other problem we did that's like this, you could do limit comparison with 1 over n again and show absolute convergence. But let's use the alternating series test here. So I think the key for this problem, even though we have that kind of double alternating part, I think we can just keep things simple here. For the sake of the alternating series test, we just care that the -1 to the n here and whatever after it we take as our b sub n. And even though sine is also alternating itself, I think we can just kind of glaze over that part. Because really, like in the long run, specifically for sine of 1 over n, because it has like the behavior like at first it fluctuates, but then it stops fluctuating and goes to 0 just cleanly. I don't think we need to consider sine as alternating in this case because of this kind of like end bit behavior where it stops fluctuating and just trails off. So I think that's kind of justification that we can use here. Yeah. So then if we do the alternating series test, we take just this bit. And in Paul's notes, they call it b sub n. If it's defined differently in your class, you might not want to use this exact notation, but like whatever's after the -1 to the n part, at least according to Paul's notes, we would call it b sub n. And the entire series was the a sub n. This whole b sub n, a sub n thing isn't that important for the alternating series test, as long as you know the most important part is that the bit after the -1 is decreasing, which this is, and that the limit comes out to be 0 of just that part there. So take limit as n goes to infinity of sine of pi over n. Here, we just plug in infinity directly, and pi over infinity is 0. Sine of 0 is 0. The reason, like the other situation we had was the limit as n goes to infinity, sine of 1 over n, I think over 1 over n or something like that. Yeah, it was this. And that 1 over n made all the difference. That's why we had to do some weird stuff with substitutions. We don't have the 1 over n up here, so we can just plug infinity in directly, and we're good. But as soon as we see the limit comes out to be 0 by the alternating series test, this entire thing converges. So if you're good with that. Yes? Okay. And then looking at 19, I think I know how we're going to do it. I want to look up one thing, though. Okay, good. So for here, we have n equals 1 to infinity, -1 to the n squared over 5 to the n. Okay. Okay. So we see a -1 to the n, so we should immediately try the alternating series test, I think. I'm going to make the claim that this part is decreasing because an exponential is always stronger than a polynomial, and the exponential is on the bottom, so we're dividing by a very big number. So I'd expect this exponential to dominate, and this is going to be decreasing. That's kind of a justification I think you would really need. Let me actually like write it out though. N squared is less than 5 to the n for large n. I think that's sufficient justification here for the decreasing bit. Now we just need to set up the limit part, which is the limit as n goes to infinity of n squared over 5 to the n. So if we can evaluate this limit and hope that it comes out to be 0, then we're golden. Now, if you try to plug infinity in directly here, we get infinity over 5 to the infinity is still infinity. So infinity over infinity, indeterminate form. Let's apply L'Hopital's. Write an LH here for L'Hopital's. N squared derives to 2n. 5 to the n, this is why I had to Google derivatives, is 5 to the n ln of 5. Because whenever I always forget the general like third of an exponential, but it's just itself multiplied by ln of the base. So now try to plug in infinity again. We get 2 times infinity over 5 to the infinity ln 5. We still get indeterminate form, infinity over infinity. So let's do L'Hopital's one more time. 2n derives to 2. 5 to the n ln 5. Well, 5 to the n derives to 5 to the n again. And then ln 5 is still there, and then multiplied by another ln 5. Now this, if we try to plug in infinity, we get just 2 over 5 to the infinity. So we get 2 over infinity, which is 0. So the alternating series test applies. That means this thing is convergent. Oh, I googled common derivatives because I can never remember how 5 to the n derives. So same, yeah. Hey, Anders. Why, Google? Fine, it doesn't matter. But yeah, have to use absolute convergent series test. So, unless it was taught differently in your class, I'm not aware of something called the absolute convergent series test. I think what you're referring to, though, is the idea of showing a series absolutely converges to show that the alternating series also converges. And it's not just one test. It's like using this fact here. So we could have also, it's not just one test, I guess, is the distinction that I would make here. If we felt like it, I don't know exactly how, but we could have also considered the absolute value of this series, which I think is what you're saying. And that the absolute value of this just means the negative one goes away, basically. Because this is always positive. So yeah, we could have shown that this thing converges, which would imply that thing converges. But the thing is, it's not just one test. Like, this is just a new problem, proving this thing converges. So you're allowed to use any other test you want, you know, integral test. Actually, the integral test will probably work here, but it'd be a little bit of a pain. But yeah, you can do an integral test, comparison, limit comparison, any test you want. So that's why I'm saying it's not just one test. It's more making use of a fact, I guess. I'm not sure like the best way of like phrasing that, but it doesn't answer your question still, which is how do you know when to use the alternating series test versus this approach down here with absolute convergence? And I would say you almost always want to try the alternating series test first because it's relatively quick. And only then take the absolute value and look for absolute convergence, because this is like a whole new can of worms to evaluate this series without the benefit of it being alternating. Like the alternating series test is great. I always want to use it as much as I can. And I'd only look for absolute convergence if this limit doesn't work out for some reason. If you want to see a problem too, I'm happy to work through it. Okay. You know, I'm actually curious. If the limit isn't 0, does that mean it diverges or just inconclusive? I think it means inconclusive. Yeah, I think if your limit doesn't come out to be 0, you're inconclusive, not necessarily divergent. Ooh. So this one is actually it's going to be the opposite of what we were just talking about. This one's be conditionally convergent, which maybe I'm jumping too far ahead, but let's work through the problem first, and then we can talk about that more in a second. Think I got that right? -1's the n minus 1, cube root n squared. Okay, cool. Okay, so first step, let's try the alternating series test. 1 over the cube root of n squared is decreasing. And then the limit as n goes to infinity of 1 over the cube root of n squared, that's just 1 over infinity is 0. So I'd say this is where the alternating series test really shines, where in 2 lines, this is just a convergent series. We didn't have to like invent a new series to compare it with or anything creative like that, which is why I really like this test. Now, I think maybe you're bringing this up as an example. Like if we tried to prove absolute convergence here, that would not go so well. And that's because if we consider just this series without the alternating part, well, the cube root of n squared, if we use exponent rules, is the same as 1 over n to the 2/3. And that's a p-series that diverges because the exponent is less than 1. Less than or equal to 1. So when the alternating version of a series converges and the non-alternating series diverges, I believe that's called conditionally convergent. Okay, cool. I tend to get that terminology wrong. Sine of 1 over n is still tricky. I observed that when n increases, does it? Thanks, Enigma. The sine of just 1 over n1 is tricky? I don't know what's wrong with just plugging in infinity for n. So I think there's something that like I did wrong for my explanation for critical, but I think we're okay. In the meantime, I'm gonna look at this one. I did it right? Okay. Oh yeah, that term conditionally convergent. Wait. Oh, never mind, never mind. Yeah, that's what I was saying. Okay. So we have cosine of n pi over 3n plus 2. Okay. So we're gonna have to do the same. We're gonna have to translate this cosine n pi into a -1 to a power again. Well, I mean, not again, because the other time was with sine. So I guess I keep trying to make rules to help you out, and then I realize that we have to break those rules when these more complicated series come up and you get more tools in your tool belt. Sine and cosine often you want to do comparison tests for, but then there's this exception. You know, I've been telling you that, like, you know, use comparison tests with sine and cosine, but we're seeing today why that rule maybe isn't the greatest generalization. So my bad on that. Because if we have, specifically in the situation cosine or sine of n pi, those are generally going to be really nice numbers that we can convert into a -1 to a power. 3n plus 2. So I'm trying to think of maybe if there's a weird situation this rule might not apply, but if you have like cosine or sine of n pi or some kind of thing where you can use the unit circle to get clean values, it's generally a good idea to do that. Can you also do comparison tests here though? No. Comparison tests wouldn't help. Actually, that's an interesting thing to show too. So I was thinking if we did try our cosine is at most one trick, and we tried to compare it with 1 over 3n plus 2. 1 is greater than or equal to cosine, but 1 over 3n plus 2 diverges, and our inequality is going the wrong way. So the comparison test actually isn't helpful here. But either way, I'd say I'm just kind of doing that as a demonstration. If you see cosine of n pi, I'd say your first thing should be to convert it into a -1 to the power. But if you were to try my like bounding trick, it's not going to work here. Yeah, no, we should definitely make this an alternating series, but I just want to show like why the comparison tests might not, or it wouldn't like work out here. So let's make a little like sine chart just for that cosine of n pi part, just to figure out what the pattern is supposed to be. Let's just do n equals 1, 2, 3, 4. Probably don't even need all 4 of these, but let's just do it. If n equals 1, cosine of pi is -1. If n equals 2, cosine of 2 pi is +1, right? If n equals 3, cosine of 3 pi is like cosine of pi, which is -1. And then 4 pi is going to be 1. Okay. So we're starting now at n equals 1. We have to remember what our starting index is, and we want our first term to be -1. Those are the 2 pieces of information that we need to do this like translation. Oh my god, I did it again. So I'll start by writing -1 to the n just as a good base. if we plug in 1 for n here, we get -1 to the 1 is -1. So we start our first term at -1. That's what we want to match this. So we're good with just -1 to the n. We don't need to do +1 or -1 or anything. So our series really is -1 to the n over 3n plus 2. And now I'd say we want to do our alternating series test. So just 1 over 3n plus 2 is decreasing. And the limit as n goes to infinity of 1 over 3n plus 2, we have 1 over infinity is 0. So by the alternating series test, since this came out to 0, this thing converges. Oh, good. You even sorry that I missed that you found that for yourself, but yeah. Right. The absolute value of the series does not converge because it's just a transformation of the harmonic series, and the harmonic series diverges. Absolutely, it is not absolutely convergent. So yeah, I hope that's good with you, critical. Just out of curiosity, I assume this time of year you're gonna have one more? Yeah, sure. I assume you're gonna have like a test at some point soon. Is that still is that like coming up soon? Oh, three weeks. Okay, so that's sometime. He said sine of 1 over n. That's crazy. But yeah, I'm happy to keep. Oh, you already posted it? Okay, cool. I see it now. Was there a mistake when we said before SPQ? Gave me a problem before. Oh, sine over n. Oh, sine of n to the over n to the s. Oh, okay. You want to points today? You should have had you draw yourself celebrating your affiliate anniversary. And I'm just drinking water right now. This thing always has water in it. I try to drink my tea off stream but before I start, but if I'm drinking on stream, I usually just got a late start to the day. Oh, right! Where the pi was inside the parentheses. And you were talking about the version where pi isn't inside it? Or were you talking about the version with pi inside it? Oh, dang, I did the same thing where I ask you both sides of the yes or no, but with pi inside, it's clear. Okay. Yeah, I think either way it's convergent, but if the pi wasn't inside, it's a way harder problem. Okay. Yeah. That's still terrible notation on the book's part, though. Sine of n over n to the s always seems to converge. For s greater than 1, right? That makes sense to me, I guess. I mean, can you just always compare it with, well, I don't know. Maybe you can. Maybe you can. No, I don't know. For s greater than 0? If s equals 1, then that should diverge by the divergence test, right? Because the limit is 1. Maybe I don't remember how the exact problem was set up, though. So anyway, for this one should absolute converge. I agree. I would add a caveat, though. Wait, sine of n over n go... did I say it wrong before? Oh, no. Yeah, I'll show you how. Oh wait, but we have as x goes to infinity in our problem? Wait, I'm getting worried. As x goes to 0, the limit is 1. No, so yeah, what I did before was fine. As it goes to infinity, that's where... Okay. I just had it backwards. Okay, yeah, I guess you're right then, SPQ. Okay, so the caveat that I want to add here is that we have sine of just n. So the thing we were doing before with like the -1 part does not apply, because you need it to be like pi n or pi over 2n or something that gives you a clean unit circle value. Sine of 1, sine of 2, sine of 3, that's not a unit circle thing. So we don't get to use the same trick. We should go back to our old tricks of remembering the bounds of sine. Okay. So, like I said, I don't see like a pi n or some multiple of pi times n inside the sine, so we can't do that alternating series trick. So at this point, I would remember that -1 is less than or equal to sine of n is less than or equal to 1. And, well, actually, I should back up a little bit. Well, I guess this is involved in it. On top, we have 1 plus 2 times sine of n. That's going to be a pretty small number all the time. Like, sine of n isn't particularly... It's stuck between -1 and 1, so this numerator is never going to get very big at all. It's going to be at most 3. Whereas n cubed is growing very fast to p series with p greater than 1. So I'm going to suspect that this thing converges and find a series that's greater than it that also converges, so we can use comparison. So, so I want to name a series that's greater than sine. Well, we can bound sine from above by +1. So let's do that. Let me write the original series. Is less than or equal to, by this logic right here, (1 plus 2 times 1 over n cubed. And now let's simplify the top to be 3 over n cubed. Now this is just a p series with p greater than 3. So, or p greater than 1. So when p equals 3, this thing converges. And since this series over here is less than a convergent series, then this thing must also converge by the comparison test. 1 plus 2 sine of n could be negative. True. I think what I said is still true, but I didn't use the right reasoning. Because if anything, it sometimes being negative is going to help it converge. Oh, I don't have that. I don't have any music commands set up. Unfortunately, it's a music player that I use. Probably wouldn't like it if I did that, but if you were to look it up on Spotify, which I'm definitely not using Spotify because that's against terms of service, is Synthwave Night Drive. This track is Paradise by Voyage. Standard test requires asymphony and beastmen to both be non-negative. So I think it's Spotify that doesn't like Twitch. You're not supposed to use Spotify as a music player on Twitch. And so there's a way I can still make a song command work, but I'm a little bit worried. I mean, I'm a little bit worried that like Spotify could catch on to that or something. No, Stooky, I believe plays it through Chill Hop's website, which is completely allowed, and that's what you're supposed to do for Chill Hop. I don't think it's particularly like if you're a small streamer, it's probably never going to affect you. I'll play by those rules. I'm playing. I mean, I'm definitely not playing copyrighted music. But technically, no stream is supposed to use Spotify. Many streams get away with it though. Yeah, so I think that's the key here. So wait, Crickle, you were asking a question before that though, right? Or what makes a series special is absolute convergence series? Okay, yeah. So we do have to consider absolute convergence here. I did miss. It's possible for this numerator to be negative because if sine is -1, you get 1 plus -2 is -1. So technically, we should be interested actually. The same logic is still going to apply. We just need to. We're not being very rigorous though. Because this, in a way, it's alternating, but it's not cleanly alternating like -1 to the n. This is where we need to use absolute convergence. So like if I'm being fancy, I'll say like consider the absolute value of this. And we show that this thing converges absolutely. N cubed is always positive because n goes from 1 to infinity. So I'm going to make the absolute value just on the numerator. And now we need to bound the absolute value of 1 plus 2 sine of n. And I would just do this simply by thinking sine of n at its best is +1, so 1 plus 2 is 3. Sine of n at worst is -1, so 1 minus 2 is -1, which becomes 1. So this is still bounded above by 3. And so now from this, we can say that n equals 1 to infinity of 1 plus 2 sine of n over n cubed is less than n equals 1 to infinity of 3 over n cubed. And now by the same P-series thing, we can show this absolutely converges, which means the original series also converges. So yeah, that's good catch, Stone. Thank you. No worries, critical. Glad to have helped. Gotta go work? All right. Well, good luck at work. Sounds good. See you around. Oh, okay. Today's been zooming by. Uh, 4 hours, and we have only taken questions from chat, which I absolutely love. Maybe we'll do a bit of abstract algebra before we wrap things up for the day. Algebra equals Pog. Are you in chapter 4? No, I haven't even read chapter 4 yet. I was gonna work through some of the end ones at chapter 3. There's still some that Penn called out from chapter 3 that I haven't done. And then I'll probably read chapter 4 off stream and go back. I'm probably gonna do some more from chapter 3, just like use up some time, but I don't want to go on to chapter 4 on stream until Penn's done it on his stream. And Penn's going on vacation starting, I think, today, so that'll be a little bit of a break from this, or I'll spend extra time on chapter 3 or something. Not sure. Okay, so I remember doing 72. SPQ pointed out that really nice formula that the order of this set is the order of A times the order of B divided by their intersection, the order of their intersection. So oh yeah, so for this one, 73, I think I did the problem as the book stated it. I remember SPQ saying that there's a more interesting version of this problem that I don't remember. Sounds like if you want to discuss this more, like, let me know, or if you similar like what you're saying before. But if not, I'll probably just move on to 74. If K and H commute, then KH is a subgroup. And K and H are both independently subgroups of G, but their elements commute with each other? Or what was the relationship here? Okay. I guess it'll be using the same argument, but this is, your version of the problem is more interesting because it's more general. It doesn't have to be the entire center. It doesn't have to be the center at all necessarily, I guess. But it definitely does work with the center. I wrote K first, and that's weird, but I'm rolling with it. HK equals KH for all H and H and K and K. Oh, good. Lowercase k, uppercase K. They definitely look a lot different. Then KH equals. I keep writing it backwards. So I don't know my alphabet. So we have proof with H substituted for Z and G. Yeah, so I think it'll be the same like structure, but we'll still go through it. Okay. Of 6. Okay. Wait, are we saying KH or HK? This is annoying me now. All right, okay, SPQ said KH, so I'm saying KH. I don't remember how the alphabet even works anymore, so who cares? So I guess first we prove that it's going to be non-empty. E belongs to K and wait, H, I, J, K. Okay, H does come before K, but who cares? And E belongs to H. So equals E belongs to HK. Wait, now I said 8. Oh my god. Can also prove that KH equals HK. Oh yeah. I mean, that seems like obvious, I guess, or I don't know if there's like some nuance there in the proof. Actually, I guess if we're putting, I guess I didn't really notice that. If you're, we're saying it's commutative, but you could also make some kind of KH group that's not commutative, I guess. So I guess that's where the ordering of the letters is important. All right, so we said KH is non-empty. We want to show it's closed. Let A belong to, or A and B. KH, A equals K1H. H1, B equals K2H2. So then AB equals K1H1, K2H2. And since they're commutative, we can say K1, K2, H1, H2. And since H and K are closed, these things are, the K1, K2 is in K, H1, H2 is in H, so their product must also be in KH. Now I have to show inverses. And we're going to say that A inverse is equal to H1 inverse, K1 inverse. And since these are commutative, we can say it's equal to K1 inverse, H1 inverse, which also belongs to KH. Okay. See, I think that's the same exact like structure I did for the other proof, but it's good to see that like more general version of it. So 74, if h and k are non-trivial subgroups of the rational numbers under addition, the trivial subgroup is just the identity. Rational numbers under addition, our identity is going to be 0. A non-trivial subgroup, that would be every multiple of a rational number. Every integer multiple. Because you need your negatives in there. And there's no other subgroup that's possible for rational numbers under addition. So otherwise you're not closed, or you don't have inverses. Okay. Prove that h intersect k is non-trivial. Really? Oops. Those are non-trivial cyclic subgroups, but those aren't all the subgroups. Really? Okay, so there's a different kind of subgroup? So I'm thinking that, like, the subgroup generated by 1/2 intersect the subgroup generated by 1/3. Oh, they have common multiples. Okay. Like 1/6 is going to be in that intersection. I missed that 1/6. Would be in there. Okay. So that's gonna how we show it's non-trivial, but like, what's a subgroup that isn't cyclic, I guess? Or like, is there an example of a valid subgroup that, like, you know, is just like generated by a rational number? When I have a 30 give you 1, not 1/6. Oh god, am I bad at math? I'm thinking multiplication. Oops. Yeah, they would cross over at every integer. Would they cross over? No, they never cross over at a rational number. It's not an integer. Oh, finally generated subgroups of Q are cyclic, so you have to come up with a weird one. Oh, okay. And actually, even if it was multiplication, it'd be powers of 2, so there wouldn't be any. Those intersections would be empty, but this isn't multiplication, this is addition. So I guess the idea is, okay, so to prove that h intersect k is non-trivial, we just need to prove it has anything except for the identity. Well, I guess we need to prove it's a subgroup, but also we need to prove it's a subgroup, and then we need to prove it's non-trivial, I guess. Well, actually, no, we already know the intersection of two subgroups is a subgroup. We can use that. Okay. We've already proven this, that piece of it before. So I think as long as we can prove there's something that's not the identity, we're good. Because we've already shown that h intersect k is a subgroup. And I think we can construct that. Yeah, we can absolutely use cyclic subgroups if the only task is to name another element that must be in this set. Well, yeah. I mean, unless they're, I don't know. I'm gonna go with my idea though. I assume we're not supposed to come with some super weird, exotic like definition of a subgroup here. So, I guess we'll let H belong to H and K belong to K. Well, do we need to name something in their intersection? Shoot. Okay, my idea is to basically since H is in H, NH is in H for all n belongs to integers, right? And I want to make the claim that if n is every integer and h is of the form a over b, eventually n is going to equal b and you get an integer. But that's not really good enough because we need to show it's the same integer as the one we get from the same argument as with k. Or we need to show that it covers every integer, which is probably better because I think it does cover every integer. Oh, okay, good, SPQ. I guess that's kind of what I just said. Like, I guess without realizing it, I kind of accounted for that with saying this, like, even if it's not a cyclic subgroup, it must contain that cyclic subgroup. Since H is also in, oh my god, in Q, let H equals A over B, where A and B are integers. That looks like 22. So can we say that since n is every integer, n will eventually be every multiple of b? And that you're going to get, therefore, every multiple of just a, including h? I guess that's my idea. And we can apply the same argument then to k. So h intersect k will always have the entire set of integers at a minimum. How am I going to say this though? I'm gonna write this, like, consider all n's of the form n equals mb, where n is an integer as well. We have a lot of constants being named here. We have nh equals mb times a over b equals ma in h. Oh wait, this is every integer multiple of a though. No, that's not what I thought it would be. I thought it'd be every integer. It's not every integer though. It's just a multiple. Oh shoot, I didn't even think about that. Like if you have 2/3, you'd have every even number. Oh, that sucks. H intersect Z is equal to AZ. Oh, that's a more succinct way of doing what I just did. Yeah. That's probably a better way of writing it. That skips over a lot of what I just wrote. But we have an issue here where what if all our A's are evens and then all our, whatever we have for K is odd? How do we overcome that issue? Can we somehow transform K to make it fit? Or for that matter, transform H to make it fit? I don't really see how. Since AZ intersect BZ can't be empty, or can't be non-trivial. How do we know that AZ intersect BZ is non-trivial? You're good at SPQ. Oh, hey, Miguel Hoffman. It's going good. How about you? If H has an integer in it, is there some multiple of it that's guaranteed to be in K? That's a nice way of framing it. Oh. I keep thinking of multiplication. Because I was thinking, I literally said if one of them is every even, the other one is every odd, then they'll never intersect. But if you do an odd plus an odd, you get an even. Okay. Just doing an essay? Oh, nice. Good luck with your essay. You have H equals A over B, K equals C over D. How do we apply the algebra? So we take every multiple of an arbitrary integer can we say they're guaranteed to eventually meet? Well, every pair of numbers has a least common multiple? Okay. So H intersect Z is the integer multiples of A. Likewise, K intersect Z is C times Z. So then these two, if we intersect them, is non-trivial because the LCM of AC belongs to this intersection, right? And that's our proof. Oh, wait. So LCM of AC, we can be like explicit about it, belongs to H intersect K. So H intersect K is non-trivial. Oh wait, and is not the identity. Because their least common multiple can't be the identity. That makes no sense, right? I think that's okay. Yeah, good catch with that SPQ. Okay. Thank you both for the help there. SPQ and Phobos. All right, so 75. Oops. Let H be a non-trivial subgroup of the group of rational numbers under addition. Prove that H has a non-trivial proper subgroup. Let H be a non-trivial subgroup of the group of rational numbers under addition. Can you make infinitely many? Actually, no, I mean, doesn't this mean you can make infinitely many proper subgroups? I guess if you keep taking multiples of whatever your like second number is. Because we could get to the, I assume we could get to the same argument that we're going to have integer multiples in there. So you could always take another proper subgroup if you just start your integer multiples from the second one in that list, I guess. That's kind of funny. So I think I just kind of said the essential idea of the proof, but let's try and write it out. So we're gonna start it similarly by saying that if H is a non-trivial subgroup, then we can name an A over B that are lowercase h's. I probably just use SVQ shortcut of going straight to the intersection here, so we don't have to repeat the entire argument again. Goodbye, marker. H is in Q. So let A, oh my God. H equals A over B. So that means the subgroup generated by H is an H. I don't know if I might be going a little like crazy with saying all this stuff. The subgroup generated by H. Well, no. The subgroup generated by H intersect integers is equal to every integer multiple of A. Well, that's a nice way of setting this up. Okay, so let K equal to A for all, oh wait, no. For all A in, I guess this intersection. Or I guess in AZ. Wait, I should, well, let's say B, or no, I guess C. For all C in AZ. I think when you say K is less than or equal to H. I think that's the idea, if I actually try to write it out. Assume that A and B are co-prime. Oh, yeah, I guess we should have stipulated that A over B is in simplest form, or as you say, co-prime. Always we only have the integer multiples of A are a subset of the subgroup generated by A. Yeah, if A and B aren't coprime, what does that mean? Yeah, I guess it is inconsequential for this, but oh, the subset goes the other way. Yeah, I'm trying to like. I understand that like A and B not being coprime probably causes issues. I'm trying to figure out the exact issue, I guess. So if you have say 4/8 and you take every integer multiple of that. Well, 4/8 is a bad example because that consider 1/2 equals 2/4. Oh, okay. Yeah. So I guess in my thing with 4/8, you would get all the integers, all the multiples of 4. But technically, you could get every integer if you reduced it. Yeah, I think the argument still works, but you're right. There's like a subtlety there, I guess. The h be a non-zero integer from h and k be a non-zero integer from k, then hk is in the intersection. Oh, I guess so. If you can just jump straight to I was proving that you have integers as multiples of rationals. But yeah, I mean if you just like set that and take non-zero integers, and I guess you're fine. Okay, I didn't have to say LCM at all in the previous proof. I could have just multiplied them. Yeah, and you're right, it's SPQ. We're fine either way. Since chapter 4 is for the future. Okay. Fair enough. All right, so we're on what, 76? Prove that a group of order n greater than 2 cannot have a subgroup order n minus 1. Oh god. Okay, so if you chop off just one element, you cannot possibly have a subgroup. And I assume this is finite order, unless we want to say you can have infinity minus 1. I feel like I understand the gist of this, where if you have a finite group, Um, what am I trying to say? If you have a finite group, you have to have the subgroup generated by each element of that group at a minimum. And there's going to be some argument with closure being broken if you chop off just one of the elements, because you never have an element that generates a subgroup of order 1 besides the identity, but you need the identity. Is that the argument, I guess? I mean, no, I need to connect the bridge between those two things a bit more. Why does the identity being the only element of order 1 mean that this is a proof of the thing of the question? Because we can take that element and square it and say that it must be in that other subgroup. Okay, that's the argument. I got it. I'm going to call the group G. Consider a subgroup of G with the order of H equal to n minus 1. Wait. Equal to n greater than 2. Then there is a single element in G, or I guess I'll say in G minus H. Let it be small g. Since H is a subgroup, G is not equal to E. So well, what if G squared? Oh, well. What if G squared is E? Dude, I have to use the bathroom so bad. I'm gonna go. I'll be back in like 1 minute. Oh, okay. Sorry about that. I've heard a lot until the end of stream, but sometimes you just gotta go. There's a very simple, it's a very, very silly, simple way to do it. Is it like a meme way or is it like the actual best way? Because I'm kind of realizing that if G is self-inverse, this is trickier than I thought. The idea is more or less the same as mine. In a sense, it is best. Since it is conceptual. Okay. So I'm trying to make my idea work, and if G is self-inverse, the only way that we can do this is if we can somehow use the elements of H to construct a G and break closure that way. But I'm having trouble kind of doing that. Yeah, I guess I don't mind hearing your... I don't mind hearing either of your ideas then. Because I think I'm stuck on my idea right now. G squared would have been a really nice way to do it if we could guarantee that G wasn't self-inverse. Consider like H but with G also in there? Is that what GH means? The idea is that if GH intersect H is not empty, you get something weird. GH is G times every H. Basically the same, but more conceptual. I'm trying to feel like, what would the intersection of GH and H be? That would imply that G is an H, I guess, if their intersection isn't curious. Yeah, Phobos, if you want to say your version of it, it's like looking at the row for G in the Cayley table. Just n instances of X from G in the table. Removing a row and column only removes 2. Hmm. Moving the row in the column for G. SPQ keeps hitting me with it, yeah. So I think SPQ's argument is like really the same thing, but maybe more formal. I'm still trying to wrap my head around Phobos's. Is that saying that like if you remove the row and column for G, you're really removing two things, not just one thing? No, I think I'm interpreting that wrong still. Look at what SVQ was saying though. Suppose GH intersect H is not empty, then there exists an H in H such that GH is an H. But then, okay, that's a nice, I wouldn't have spotted that like GH thing, but that's the kind of closure breaking thing that I was looking for that I couldn't quite get to with my idea. How did the book intend you to, I'm kind of curious. This is 70. Oh, it's an even number. Dang it. Because I would assume the book wouldn't expect us to get a proof like that this early on, that like SPQ said. There's n instances of x from G in the table. I'm still trying to wrap my head around that, like, the explanation from Hobos, but it might just be that I'm 5 hours into doing math. At, wait, who did I just give a save to? Phobos? Okay, so then SPQ as well. I say I probably just need to let 76 marinate for a bit. Next time we do it, we can do 78, 7 and 78 as well. Then I don't know what we're going to do after that. If we continue to do abstract algebra. But I don't know. My ways may be swayed by cosets. Once you see them, you can never unsee. You've seen things. Cosets you wouldn't believe. Okay, I think I will wrap things up. I see both Zach and Dan are live, but I rated Dan. I definitely rated Dan yesterday, if not more. So, let's go rate out to Zach, I think. Slash raid e to the 2I pi. Okay, cool. So yeah, thanks so much everyone for hanging out with me for the info level with the algebra. I should, oh my god, I keep on forgetting to advertise it, but physics reading group, the thing. Is the command still not working? Oh my god. Wait, it should be working. Oh no, freaking StreamerBot. Dude, StreamerBot is really cool for some things, but this whole command thing is super lame. It makes you hit save to actually save your things. And I know it's completely reasonable, but what program in 2024 makes you hit save and doesn't just save for you every now and again? Okay, now it should be working again. Okay. That's happening. I'll probably send something out about it in the next, like, I said I'd wait until Monday, but I'm getting kind of excited about it, so I might send something out a bit sooner for like actually getting started on reading stuff. But regardless, thanks so much everyone. I'll be doing games tomorrow. hopefully Daisy, and then Saturday will be more math. So I appreciate you all, and let's go show some love to Zach.